Welcome, everybody. Welcome to the stream 61. I can't believe we've made it. Today we are doing... Hey, I'm live. Today we're doing a voice channel stream, and you can join the stream if you want. We're in the Discord, so join the Discord. We have tons of fun.
Hi, hello.
Hey, it's local. I mean low calorie.
Low calorie. Oh,
We made it.
we made it indeed.
How's my audio? Am I super loud? Do I sound clipped?
Sound
You
fine?
sound normal to me.
Hey. Am I louder than I was before?
Nope.
I have no idea.
Okay. That's fair.
I can
Anyways.
tell you that my volume isn't turned up to 150 like it was the last time.
Hey, okay, so that's good. Hopefully
I've got you 100% and you sound fine. I've got Eternal on 200 though, and you sound non-existent.
Should I turn myself up a bit more?
You can.
You got a little louder there. Maybe you were just closer to
Is
your
this
mic.
better?
Yeah, that's much better.
Yeah, well, my mic is like, it's not fully turned up because that would be too loud.
Yeah, I can put you back down to 150 and it's probably
I
fine.
need to turn you up though, local.
Hey, yo, why?
There we go.
Okay. Well, I'm glad I didn't tase on day my audio or anything. I really expected that.
I love that as a new
Oh god,
word.
that reminds me, like, Agma had a moment like that where he, let's see if I can find it. I may have showed that to you before, but he opened his stream while he was streaming.
Yeah.
He didn't notice that for like a few minutes, and it just kept looping.
Compound interest.
Yeah, this is. Hold on, I can put it here.
Okay, we're probably just going to be doing some modulos or whatever I typed out there.
I put the clip in the general chat.
Oh, in here, nice. Yes, modojoelos.
I mean, if we're pronouncing more is more, then it's just modolos.
That's true, but you gotta get a little bit of the word module in there. It's a module of this.
Mojolos?
Hey, yeah, that's good. That's good.
Just modulus.
Yeah. So last we came in, we were just doing serialization of types, right?
Probably.
Yeah,
I wasn't there.
I think so.
Yeah, that makes sense. Yeah, and then we have a type cache, so we don't do one more than... Okay, yes.
Oh god, he's still using right string to string, right?
Yes, I have not touched the code base.
Yes, that makes sense.
We can change that now.
Yes, we need to change that.
So right string to string is something I stole from here.
Yes, and the reason for the signature will become very apparent if you just scroll up to the function above and you look at its signature.
What?
Scroll up.
How far?
Scroll up and look at the signature of this thing, and then you'll see.
Ah.
And then you'll see why it has the signature it has, because it's all back to vformat to impl. That's the only purpose of this function, to serve as a callback.
And I stole it.
Yes, you did something with it.
I should probably open the stream.
Oh yeah, I should probably do a thing here.
If you've got the bandwidth, I'd prefer to watch in Discord, yeah.
We'll see what happens.
Oh, that's why. Yeah, that's why it took you, but just scroll up, I see, because of the delay, probably.
I was scrolling up and you were telling me to scroll up, and I had a feeling.
Yes,
I was like,
the
stream is very far behind.
Okay, here we go.
Okay, it's low FPS, but I am streaming in the Discord.
That's fine. That's fine.
Nice.
Nice.
Okay, so...
In case you don't know, by the way, there's a hide members button you can click to full screen the stream, because I didn't know that until literally a few days ago.
Yeah, it's such a weird button.
Mm-hmm.
The UI for the streaming in Discord is crazy.
Mm-hmm.
There's like buttons on every side, on the top, on the bottom, in the middle. So
Yeah.
confusing. Okay, so I stole write string to string. Why did I steal it?
Because you forgot that vector append exists.
Well, how does vector append work?
Vector append appends to a vector something that has a size in the data.
Right, but that means we need to create a string buffer or a span
Yes.
from the thing,
Yes.
which is exactly what write string to string does. So we basically just need write string to string, but called something else in local here, right?
Also use, I guess we don't have the format specifier for format too. So
Because we just need a
and are we appending? Because most of what we're appending are going
everything.
to be strings anyway.
No, it's not. Otherwise, I would have used something that would just append strings. Look, this is
We
one byte, reinterpreting it, the first byte of a U size. It's nothing like writing strings. I don't know what you're on about.
Wait, hold on. Oh yeah, we're writing a single byte to it. Sure.
I'm going to call it write bytes.
I like it.
In C++, I just make this a template, but
Cool. Story.
it doesn't work.
Good thing we're not doing that then.
U size. Okay. So we have this thing. I could probably just flip this around so we don't have to change all the signatures.
I would make a separate function for writing out 1 byte or something, maybe, depending on how often we need that.
Not often. This is the only time. The rest
most of what we're doing is we're just writing out byte ranges, right? Yeah. Okay.
Yeah. We're writing out arrays and structs. We're basically recreating fwrite.
Ooh.
Okay, so we write bytes to out. How do we do this? What does write string to string do? We use vector append.
You can just make a span and call vector append, is what I'd do.
So make this a span. We don't need capacity. No need to do that.
Also, it's with the source is on the left and destination is on the right. That's very confusing.
Yeah.
I'd say out should probably be the first parameter.
I'm just copying what it was already. We can change it. It just means that
Yeah,
all I'll have to do is replace string to string with bytes. I could do a regex replace.
Sure, you can also do a query replace or something.
Right.
Yeah,
we'll flip it. Whatever. It's fine.
This is like the output parameter should be the first thing, otherwise it's confusing. Also, I'd make a const UN date pointer because we don't need to write to it.
That's true. We could also make it a const pointer because we don't need to change it.
Sure. Though the span is probably gonna. Yeah, well, that's. Yeah. That's
Get
not
rid of it
exactly.
Yeah.
That's kind of missing the point, but it's not that bad. It's just more about the API of the function.
Okay, so we do write bytes to the string buffer, make a span, append the vector, do that thing. Let's figure out a query replace for this bad boy. Okay. I got to think about this. This is the first group I want to capture, right? I forgot. Do I have to escape the groups?
I'm pretty
I do.
sure replacing it manually is faster than trying to remember how regular expressions work in Emacs.
Yeah, it'll be fine.
This is more fun.
Do I need to do double? I can't remember. We'll see how it works. But basically I need to do dot star. And then I need to capture a comma. Do I need to escape a comma? Anybody know regex?
No.
I know regular expressions, but not Emacs regular expressions. Those are different.
This isn't going well. So I want to do anything up to a comma. Oh God, I closed it and it went away. Fantastic.
Hold on, wait. do we have?
I'm timing this, by the way.
Oh no.
Oh,
There we go.
Okay. You're timing this?
yes, of course I am. So we're at
No.
45 seconds.
Oh, that's no good. Okay. So this should match this thing, right? We need any amount of
no idea.
spaces. Is it like this?
I have no idea.
I'm wondering if your escapes are wrong on your parentheses. Am I wrong, or are they backwards?
This is Emacs. Everything is backwards when it comes
That's
to
why I'm not sure. Yeah.
This should be a group,
Okay. So
and
an escape
this should be a
paren.
literal. Yeah, this should be a
Yeah,
literal
in,
paren.
in normal regular expressions, the regular parenthesis is a group, and you have to escape it to get the character, which is more sensible because it's less typing.
We're gonna try it.
Okay, let's see where this goes.
Well, the problem is I need to keep these too, don't I?
Yep,
You
probably.
would need to also capture. Yep.
This is a mess.
We're at 2 minutes now.
Okay, so 1, 2, 3, and it's gonna be 3, 1, 2 next. Yeah. Okay. /3.
1. There you go.
/1/2. Did
Okay, let's see what
I matched the semicolon. A? That looks right. Hold on.
Let's
It is working, I think.
Let's go. I had the sad horn at the ready in case it didn't work.
Why is there so many? Oh, it's casting to const char when it wants a uint8t. So I just changed the parameter type instead.
Yeah, maybe make the parameter a const char pointer.
Yeah, that's fine.
That works.
I don't have to do this cast then, right?
That's irrelevant. You can leave that. You do need the casting because a span. You do need the. Oh no, a span is const. Right.
Yeah,
Never
I was
mind.
gonna
Yeah.
say span should be const.
But even in the function, the casting away const is fine so long as you're not modifying it. Because what you can't do is when you have a const pointer is you can't. What was it? Either the underlying object must be non-const or you must not modify it. Then you can cast away const. If either of those. So if it's either not const or you don't modify it, then casting away const is typically fine. And that's why casting away const is typically not fine, because one, you typically don't know that, and secondly, if you're gonna cast away const and not modify it, then what are you doing? So that's why casting away const is typically sus, especially in C++, and you only really do it if you need to interact with badly written libraries.
Oh dear.
That's literally the only reason to use const cast to cast away const in C++.
Basically never do it.
Yeah.
The Hobbit 1, 2 okay, you know who you are. Thanks for the follow. I read that one wrong. What am I doing?
Basically, const cast is one of those things. It's like volatile. It's if you don't know when to use it, don't use it. You need to ask, don't use it.
That's right. Okay, everything compiles, so it should be fine.
Famous last word.
Static. I can't believe that we caught 2 giant bugs in the compiler this morning. Thanks to Mugame, Mr. Magoo.
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 And
it just sounds like a sound effect you read in Japanese.
Mr. Mugame, you're here. It's me. It is you, Mr. Mugame. We appreciate you. Okay, so we should be fine now, yeah? To get rid of this.
By the way, you can really, if you go to What we should probably really do is in utils.h replace string buffer with just type def vector of chars to string buffer, because that really doesn't need to be a separate struct. That like makes it clear that this is just a vector.
Why is it mad now
What's it
though?
complaining about?
Unknown type name.
Sorry, what? What is it complaining about?
It's just clangd. It'll compile.
Is it?
Yeah,
My
I've ran into. Okay, no, I lied.
Are you including vector.h? I bet you're not.
No.
And now we gotta make sure that vector.h doesn't include utils.h.
That's probably the issue. Yeah.
So put it in vector.h instead, maybe. But that's annoying. Hold on.
Yeah.
Yeah, we can. Oh, that is annoying. Okay, that's why I did it this way.
Yeah.
It's starting to make sense.
We'll just keep it.
It's starting to make sense.
This is technically a vector char, but circular dependencies go burr.
Mm-hmm.
Yeah, we'll just leave it one line. Cool. Okay, string buffer. And everything is compiling, or it was. Everything is compiling now.
Oh God, what is going on here? What did you do?
No, it's working.
Okay.
Yeah, factorial's working. There's some warnings.
Yeah, those are interesting. This is starting to look like SQLite.
Well, here's the thing. I refactored everything to use the MIR, and the MIR has registers. But we already had registers in the x86 code gen. So we have register descriptor, which is an enum, and then we have a long unsigned int.
I don't think it's an enum because it's an unsigned int.
I think we have a negative one. I don't know.
Well, an enum is always an int in C, that's why.
Isn't it an unsigned int if there's negative ones?
No. I'm pretty sure it's an int by default. But I can check the standard.
Oh, if there's not negative ones, I'm saying it backwards, but I think you know what I mean.
Yeah, I'm pretty sure it's always int as well.
What enums are in the standard?
You're probably right. I don't care. But yeah, basically this is just the MIR converting into the old register type that we had. And I just there's no real clean way to fix this other than adding a cast in every single one of these places.
Yes, that is the way to fix it.
And that's not a fix. I'd rather have the warnings.
What you do now, you'd rather have the cast. So what you do is when you encounter a W conversion warning, there's two things you need to do. You need to check, you need to take a look at the warning and consider the possible situation. Like you need to consider, can this ever be negative and so on. Like if you're casting from or converting from signed to unsigned, you have to consider what happens if it's negative, and you have to add code to handle that case if that's possible, and then insert the cast. So what you shouldn't do is just insert the cast without thinking, because that kind of defeats the purpose of the warning. It's there for a reason, because these things lead to bugs. So when you encounter a warning, you had better think and not just insert a cast. But once you have thought about it, you should insert a cast so that people don't have to think so that the next time the warning doesn't come up and you don't have to think about it anymore.
Then if anyone...
The other problem is, what if there is an actual warning in there and you're missing it because there's 40 W conversion warnings and you're just skipping over those? That's the other problem.
That's a risk I'm willing to take. The major issue I have is that if we change this underlying type of whatever this is, then all the casts will still be valid, but it could just be a totally stupid cast that we don't want to make. The casts stay even when the underlying types change, and that's just a mess. So if we decide like, oh, our MIR registers shouldn't be U-size, they're going to be signed types, then if here we convert it into like a uint8t or an int8t, then it's going to change things based on... It's going to be a mess.
That argument doesn't work though, because that presupposes that you actually look at the warnings, which you're not doing. If you read through all of the W conversion warnings every time, then sure, you could make the argument that having them there makes you think about whether it's whether it's correct or not. And sure, the cast silences the warnings, but if you're not looking at the warnings to begin with, it's better to look at them once and then silence it. And then if you need to change the type of something through an entire code base, I just rename everything that has that type temporarily. Because that way it fails to compile everywhere, and you have to actually re-examine every situation. Like if you need to change the name of a struct field, of a struct that's used everywhere, rename the field temporarily, and then manually check every like place where it fails.
Right. So you're describing like a solution around these broken casts. You're saying just rename the field temporarily to be able to find all the solutions.
If you need to change the type of it, then yes. What I'd actually do in this case is think about whether the two really need to be separate types.
They don't anymore. We can just get rid of register descriptor, but then the thing is we're doing a bunch of comparisons and like switches. So then we're going to have to move the casts there.
Both of these are unsigned, so if you just make register descriptor an unsigned long, or a U size, it should probably work.
But it's an enum.
Or make the other one a U32.
But is it? That's what we were asking, because it says it's an unsigned int.
It should be.
An unsigned int is a U32.
Yes, but he's saying, is it an enum?
I just wanted to verify. That was the original presupposition, was that it was in fact an enum.
It is. I'm pretty sure it is not an enum.
It's somewhere.
It's in Cogent Forward.
Why would it be there? You
because
wrote this.
It's that old. The only thing we had at the time was Cogent.c and Cogent Forward.
That's probably true.
There you go. Line 11.
Where did I miss it? Oh, I did miss it.
Line 11.
It's a type def unsigned. Why are we doing this?
So now you can just make it a type def long.
3 months old or whatever. Or you can look at the git blame for this or something.
Maggot blame. Also, someone said Maggot and it kind of hurt my head. Was that you, local?
No.
Okay, it was somebody. And it kind of like, it confused me because I've never even considered that's a possibility.
Me either, because git is like an actual word.
Right. It was you.
I know it was me. I added that. You set it to int, I think, originally, which made less sense. When was it?
It won't tell me because I changed
like
it.
9 months ago.
2022. Would you look at that last year, apparently?
Yeah, there you go.
Oh, yeah, that's why it's an unsigned.
Because it was done last year.
Yes.
That's not bad.
8 months ago.
8 months ago, I was still working on this.
That's at August, I think, or September, so longer. 10 months ago.
I feel old.
That's why.
So I just need to write 4 bytes for the name length. What is the name length?
What is the name length?
Of a named type. What is type? Oh, I did a thing, guys. I don't know if it's gonna work, but I did do a thing. I should have Corfu now, or whatever, working. It's not, but it should. Oh, geez, that's usual debrief. Oh, I know what I have to do. I forgot to, I made a backup and then didn't install it. Hold on, slight Emacs configuration moment. We'll be there. I've got completion to do.
Also, 1 sec. I'll be back in a couple of minutes.
Okay.
You just keep going.
Yes. No. We're going to stop and wait for you.
I'm still looking for a SEGFAULT.
When you said going, I heard gong.
Oh. Interesting.
You haven't played Elden Ring, have you?
I mean, I have.
You have. Then you know about
I don't know what you're referring to.
You don't know the they're the enemies. They're big crystal enemies that you have to crack and then you do a ton of damage.
Oh. Yeah, the Crystallians.
Yeah. The sound they make.
I don't remember that sound at all. I fought like half a dozen of them.
That's crazy.
What the heck?
Yeah, it's just if you listen to them, it'll make sense. I promise.
I'm gonna go play Elden Ring again, and then I'm gonna either get sucked in or overwhelmed again. I'm waiting for the DLC basically to be announced, and
That's-
then I'm gonna hop back in.
I'm the same way. I made a second character. I got halfway through the game again, and then like they announced the DLC, and I was like, I'll just wait.
Uh-huh. I mean, we have some good assumptions about when the DLC is going to show up, so you can like kind of prepare. But if any of your assumptions are wrong, you're just going to be like, "Wow, that was a waste, stupid."
Yeah, it's I never put any bets on anything from Software.
There are some trends, obviously, but yeah, you can't pin them down.
Oh, do you see the pretty? Look at the pretty completion I have now.
Hey yo, that do be pretty.
Yeah, it even inserts the temporary in like a gray color, and it works way better with sizing. Look, I can have big completions and small ones. Remember that was all broken before?
Nope, I don't remember.
Remember? Oh yeah, and it was broken if I put if I didn't truncate long lines. So like if I had a really long line like this, they had to be wrapped. Otherwise my completion would be off the side of the screen. So I couldn't have it like this. But now I can. I fixed it.
Let's go.
Sir Aid's going to care a lot about that because he hates line wrapping with a passion. And he rightly so, I would say.
I don't know. I enabled line wrapping in VS Code a while ago. Like, it has not changed my programming experience at all. So, there's my opinion. I don't give a shit.
That's a very professional opinion.
Yeah, if I'm gonna wrap lines, then sure.
They're
it'll
going to be bars.
Ooh, I love puns. Like, if I'm manually wrapping lines, though, I usually have to think so hard about it. And then if anything changes, I always want to reformat the line. So for anything I don't give a shit about, like, style for, I just let the line wrapping handle it. And it's made me care a lot less.
See, you use VS Code to do your line wrapping for you. I write a function in Emacs to do my line wrapping for me.
It didn't even work. Look at that.
Yeah, it doesn't work in Tree Sitter.
Yeah.
See, if
It worked because there's no comment there. But
so it's Tree Sitter's fault. See, it works. But the Tree Sitter mode, the stupid Tree Sitter mode, doesn't set the variable that you're supposed to set according to conventions called comment start, which is supposed to be a variable, or you're supposed to have the other in the syntax table, the comment start comment style. It's in the syntax table. That's right. Just like Control HM or something. Control HS. That's what it is. But yeah, you can see there's basically the C mode actually tells you what's the comments and what's not, and what starts the comments, as in /, which is the first and second comment of a B style comment character. It's Emacs syntax tables are confusing, but basically the Tree Sitter mode just doesn't use the Emacs syntax table. It uses a Tree Sitter nodes. And that means that if you go to like the regular insert comment, it does the block comment.
right.
It just doesn't understand line comments yet.
Weird.
Yeah, it's
When were line comments added to the standard? Like, how outdated is that?
a long time ago.
Man,
1999.
For a little while. Yeah, I was about to say for a good bit they weren't in the standard, but if it's any more than like 99, yeah, it should be supported. Even
See,
11. Like
Emacs
everything
is-
supports 11, right?
Emacs is older than the C standards.
God damn.
Or at least it's close. It's from the 71, 74 that time.
Yeah, about the same.
So we have to write the bytes of the name length, and then we just have to write presumably the name, which is this thing, but it's the data and the size. Ooh, I didn't write data. There we go. We've written bytes. It's no longer to do. What do
Any
we?
reason not to reuse your name length variable for type named name size?
There is not a reason not to reuse it. We could.
Oh.
I just, yeah, that's probably a good thing to do. Oh, why are you? Why are you mad? Oh, I just am dumb. That's fine.
Oh. That makes sense. That makes sense.
See, the delay is too large. Okay, Emacs configuration moment. There's got to be a way to change that.
No more than 250 milliseconds.
Ah, here it is. Yeah, it's 200. That's not fast enough.
Oh.
Zarias says VS Code, GigaChat. Let's just put this to 0. It might like crash my Emacs.
That'd be funny.
Ooh. There we go. It's at least faster. It still takes some time. Oh dear. What have I done? There we go.
Is Emacs slow all of a sudden?
No, I have a new configuration for auto completion. I used to use company mode. I'm trying Corfu and Cape now, but it's not perfectly configured. I've figured out this pop-up info delay thing.
I see.
Basically, it feels like the pop-up info might not be what I want either. I just do delay. Yeah, that's what it is. It's auto delay. That's why I was like, it didn't change. Okay, that can be 0.2. I don't care.
Nice.
Reload Cape. Okay, back to module C, reload. I'm gonna try it. Hey, that's way faster. That's so much better. Oh, it didn't do it that time. So you still have to give it time to try it out. Nice, but yeah, that's doable. Okay. Oh, I've got questions. Zara says, actually, Mr. Streamer, do you use evil mode? I do not. I use my own setup. It's available in GitHub. But I just use the default Emacs controls for the most part. Izidiyush says, hi, Lance. Hi, Izidiyush. Mugame, is there any good C VS Code plugin? Everything I touched so far is awful. Yeah, it's called Emacs. You should try it out. Also, Eternal, I'm glad you're back.
I'm currently ordering a Windows seal for my AC because I have casement windows.
Oh
The one
dear.
I bought is too small because the window is too big, and now it doesn't seal properly.
Naturally. Time to switch to Nano. Ah, yes. Now, sure, I use the Microsoft plugins because I'm on Windows, but they're also not great.
Yeah, you guys were talking, so I hopped in chat.
Nice. That's good. That's perfect. I don't want to install a new operating system. Mugame, why not? It's the best operating system, I promise. It's only like 1 gigabyte.
Speaking of, are you gonna move to Linux now because you were considering?
Oh no. Oh no, the pressure. Okay. The plan is yes. But if it sucks, I'm not going to do it.
I see.
I'm not like dedicated, like I'm switching, because I kind of like being able to just use FL Studio and this microphone and like my guitar.
That's problem too.
And I also have like an old, what is it? The flight stick. HOTAS, hands on throttle and stick setup. I don't know if those will work on Linux.
Write your own drivers.
They're Logitech.
Yeah, I have no idea. I don't use these kinds of devices.
Yeah, that's my problem as well, Lens. Like I did share that one Linux open source DAW that I have to try out at some point, but I don't know if it's going to replace what I've already got. I think I found a solution for my audio interface, which would mean I can still record guitar and like use my monitors. But yeah, there's so many little things on Windows that just exist and that you can use because it's everybody's first class citizen. That it's really
Yep.
hard to switch if you're using those things.
Yeah, which from I don't have, because the only thing I use is monitors, a keyboard, a mouse, a mic, a printer, and that works on Linux if you get the right printer. And
If you get the right printer.
yeah, well, when I bought this is a color laser printer, so when I bought this one, I made sure it was supported on Linux and it worked first try without any setup whatsoever.
I didn't even think about my printer, so now I've got to go check my printer. Another reason I might not be able to move.
Can I still use it?
All the devices and software that you use regularly and make sure those work, which for me is mostly
Ah.
IDEs and stuff because I don't play a lot of games and the games I play typically work.
It's gotten to the point where most of my Steam library is either fully compatible on the Steam Deck or compatible enough with some tweaks that I could probably move my Steam library. But it's not everything and it's not guaranteed. It's still like less than half my library is on the green check mark, right? So that's one facet. Since I'm not using that B drive I was talking about, I'm considering the whole just factory wipe it and use it as a dedicated Linux install that I can boot to, so I don't have conflicts on my drive or extra partitions and stuff. And that way I could have a clean dual boot with not much issue. But I don't think I can get off Windows for a while.
I'd recommend, even if you can just literally unplug one drive, that would be better for Windows probably, because from what I've heard, Windows is a bit too eager to erase drives it doesn't recognize.
It does
I've never
that
had
very.
that happen.
So if you just
I
leave
have.
your Linux drive plugged in when you boot Windows, who knows what it'll do to it.
Molly the Man, dead beef.
Dead beef. Yeah, I've never had that happen with my previous dual boots.
I've never tried it, so I wouldn't know. But that's what people are saying. What I've heard at least.
I've had it I've had like Linux EFI partitions be deleted by Windows so that the Linux can't boot.
Very strange.
Because Windows really likes there to be one drive with one Windows EFI system partition, and anything else it'll try and delete. It's really annoying.
Yeah. See, I also mentioned that I have a rogue EFI partition from an old Linux install that I can't delete, and Windows hasn't deleted that either. So my experience is the exact opposite. It won't let me delete the partition.
This was a long time ago, but I once manually had to erase a partition using diskpart from the command line because it wouldn't let me do that in like any other application on Windows.
If I recall, diskpart wouldn't let me either, which is why I gave up. But it's been more than a year, so I don't know if I'm misremembering.
The classic, did I have a really hard time with that, or do I just not remember how to do it?
Yeah.
I only know Tactics 26 says that's the reason I literally had to buy an external SSD to use Linux. Yeah.
Huh. Interesting.
That way you can unplug it.
I would probably just buy a case for this one. I think it's an HDD, so it's a bit bigger. Just get an external case, plug it in.
Oh, yeah. Yeah. That'd be good. Because it should be... Honestly, they're pretty good nowadays. We're in such a different world than we used to be. With the drives. It's really crazy to look at. Storage and stuff.
Regardless of if I use this drive for Linux, I should still probably get it fixed and use it as like a big archive backup thing.
Yeah. So we write the dummy value. Is this too long of an integer literal? Is this not standard C?
Probably yes.
Okay, we'll just go dead beef then.
UL at the end, or LLU,
Yeah.
maybe.
Yeah, if you use ULL, right? Do both work?
I always use LLU. I don't think I'm not sure how long. Let's see. We
I
can
feel
find
like
This looks
I
so
feel like I
bad.
use UL and ULL.
works. LLU also works. Interesting. Both
Cool.
work. And you can also make it all caps. And now cast it to you in 6040 because maybe it's you know, an unsigned long and not an unsigned long.
Ugh,
And it will complain if you don't do that.
messy. I think this is making sense. Very similar to what we did for arrays. We write a dummy value. We get the, well, before we write the dummy value, we get the offset to the dummy value. Then we write it. Then we write the actual type we're trying to reference. We get that offset, and then we try and write that offset into this point here.
Sure.
Okay, now we have to do the same thing for pointers. It's going to be quite literally the same thing, except it's going to be pointer too. Does that make sense?
Probably.
So we write a dummy value offset. Where to find? Yeah. So when we,
Pointers, yeah.
so if because if we have a cached reference type, then we'll just write these 8 bytes and then return the cached offset and write the cached offset. Or we'll
to write the dummy value first so we can insert it here later because we don't know whether we'll have to encode it again or whether it's already encoded.
That's right. Okay. What about primitive types? We're just going to use like an index for lookup.
Yeah, sure. We could also just write all of those out at the beginning or something. I don't know. Because we don't have that many of those. It's like what? Do we have bool?
Wait. We don't have
Do we
bool.
have bool type? We don't. So it's what? Void? And that's it?
Void,
Is it
integer, byte.
Oh, those, I suppose, yeah, those.
Removing
Sure.
to do before testing is like naming final draft.
Yeah, final draft version 4. I've had that too often when I was typesetting stuff.
Okay, so we have a bunch of... Okay, how do we do primitive? So here's the thing. You're saying we just write all of them at the beginning. That would still require us to write them. What are we writing?
Just give it, or you could make them separate type kinds even, maybe that would be an option, or just write primitive and then the numbers 1, 2, 3, whatever, for the first one, the second one, the third, or 0, 1, 2, I suppose. Like, it can be literally the simplest thing ever if it's a primitive type.
So we're going to have like some array.
Number. You don't even have to put them at the beginning. You can just put, for a primitive type, you can just put the tag and a number, like a tag and an 8-byte, 1-byte number from 0 to however many we have. So
Like this? Am I crazy?
sure.
Okay, I'm not crazy.
Wait for that.
What am I? AST.c? Yeah. We have void pointer.
That's not a primitive type.
That's not a okay, that's a... We do have void. Void is a primitive. Integer is a primitive. Well, integer literal and integer. Do we have to differentiate those?
No, integer literal should no longer exist after Semma.
Should.
Yeah, well, if it does, then Semma is pretty lazy.
Semma is very lazy right now.
Very easy to fix that.
Okay. So we have byte, integer, and void.
And the way we fix that, let's fix that right now, otherwise we'll forget about it, and then we'll be very sad when it doesn't work. Is to go to Semma to find like the main function doing the type checking.
Hey, we got a lurker in here. It won't tell me the name because I'm in streamer mode. That's annoying. Oh well.
Mm.
Starts with an S. Welcome, S.
Mm.
You wouldn't know how to pronounce it anyway, because I don't.
Yeah. True.
Sorry.
Okay, so we have T void. I'm not sure why it's mad here.
My brain really wants it to be Shay, because that'd be just the funniest way to pronounce that, but it's totally not.
Could be. I mean, it isn't Irish. It looks sort of like it, but not really.
The double Y is throwing me off.
Yeah, but double Y isn't anything.
Why can I not do this?
What are you trying to do?
It says this is not a compile time constant. What is this?
It is not a compile time constant. That is right, because it's an.
It's an
Uh,
address of a static. What?
yeah,
Yeah.
it's a late compile time constant, so well, it's a link time constant. But since when is that a problem?
Ah.
Let's see.
I've had that problem forever.
Really?
Okay.
Oh, is it
Yeah.
because of a relative order of initialization? Yeah. Okay, so in that case, you can't do this. You'd have to
How do
initialize it
I
at start.
how do I get an array?
You have to initialize it at startup, or put it inside the function.
But that we're gonna need it for deserialization. The whole
Yeah.
point is for serialization and deserialization. They use the same
Yeah, so
thing.
put it in main.
Then declare an array of size 4, and like you can make an attribute constructor function or something, or if MSVC doesn't support that, put it in main and initialize it there.
We don't.
Or alternatively,
sucks.
maybe try putting the thing in ast.h, because that might work.
I don't think it's gonna work. It's not gonna work.
Oh, because it's extern here. Yeah, that doesn't work. Oh, what we could do is what you could do is you could declare the array as extern in here and initialize it in ast.c. It shouldn't complain about that.
This is so hacky.
That might work.
Oh, please.
And you have to give it a size now, though.
Why?
So make it a size 4, whatever.
Do I really?
Yeah, you probably should.
This sucks. Okay.
Yeah.
You too.
So what if I try and do something that doesn't match the size?
Then it will complain.
If you change size, change header too. Okay, sure. Void, byte, and integers. Are we sure that's all we need?
Yes, because now we're going to remove integer literals in Sema. It's very easy to do.
Okay. Zariel says, shouldn't it be null first because there is a compiler optimization thingy?
I have no idea what they're on about.
I don't either. No. Null is last so that we can iterate primitive types by type pointer. Yeah, and then we can just say, we hit null, it's done.
We should probably just iterate over the size. That should be enough. But
We don't have the size.
You can define the size, but
I'm not doing another one of those. There's too many of those in the compiler at this point. There's little like
you can size of array over size of type pointer.
There's register count. Register. There's so many.
Right, let's eliminate integer literal in Sema before we forget about it, because we will.
How do we do that? We can't do that.
Whatever is the top level function that gets invoked to type check an expression.
Right. What are we going to do there?
Are we type checking the type somewhere?
Yes.
Okay. A very easy way to do this is to just. Hold on. This is a bit annoying. That is true.
I know. That's why we don't do it.
Why do I do that? Because I get rid of them at some point. But where?
The way I usually do it is when I'm checking a type, I return a type, and usually you just return the exact same type, but that allows me to do transformations to the type as well, like converting integer literal into whatever you're trying to type check against if it fits. Pass it by reference, same thing.
Because I'm freezing them somewhere. That's type in Where am I? I'm doing that somewhere. I'm pretty sure I am. I mean, for encoding purposes, integer literal is the same as integer, so you can just use integer. But I'm pretty sure I'm. Oh, maybe I'm doing that in CodeGen. That might be the case. Yeah, that makes more sense. Hold on.
CodeGen makes sense if you really need to depend on platform types, but you could also pass that in as like, okay, well, we're compiling for this platform. We can look it up before parse, and so Sema has it.
I think I'm doing it in CodeGen. Hold on, let me see. This file is too long. It's 1,000 line of utility functions before we can get to CodeGen. Where's compile here?
I thought that was a medium-sized file.
Yeah, either. Where is it? I'm pretty sure I was doing that somewhere. No, I'm pretty sure I just have fail saves in case that just treat integer literal as I64. Interesting.
That's what I do.
Sure. So what you can do here is just encode t integer literal as integer, is what I do.
Well, that's a whole thing. That sucks. That breaks the whole system.
Why?
Because you can't just say, oh, compare it against each one in the array, and then whatever one in the array it is, give me that index.
Well, if it's none of them, you just compare it. You just compare it to integer literal beforehand.
That's so scuffed. That's stupid.
Okay, for primitive types, I typically hard code those because there's like a handful of them.
We are hard coding them.
I don't think I have an array of primitive types anywhere in my compiler.
Good for you.
I just know what the primitive types are. And if you add a primitive type, then first of all, what are you doing? Secondly, then you have to go through everything, sure. But that happens like every once in a blue moon. So
Yeah, until we add bool.
Keep coding, Lens. Stop listening.
I know.
Only code.
He's a fearmonger.
Speaking of fear, where the fuck is this seg from?
So uint64t index is going to be equal primitive minus primitive types. Corfu, JSON RPC error. Egglet is failing. Wonderful. Okay, primitive minus primitive types. Why are you mad?
What?
How's it going, local? What are you doing?
SEGFAULT. Somewhere in the parser. I am printfing here
Eternal,
until I find it.
if you're talking, you are not coming through.
not.
Okay.
Yeah, you're just green for some reason.
Okay, I wanted to make sure. I saw the greenness.
Okay, so it's happening
By the way,
in...
you shouldn't have to do address of primitive types at 0. You can just do primitive types.
Yeah, it was me trying to convert it to a uint64t, I now realize.
The difference between 2 pointers is point to diff t, which is signed. That's
yes. Write bytes. So we want to write to out.
I think a single byte would be enough for the index.
That's a good point. I figured 8 bytes would be fine.
We're going to have a lot of primitive types, just so you know.
Yeah.
Not a lot of them, but they're going to be used a lot, is what I meant.
Right. Hopefully.
So that's if they're easy to encode. God damn it. It's too high up. There's an insect on my wall and I can't reach it because the ceiling is too goddamn high.
Simply get taller.
Sorry, what?
Tall.
I don't know why that made me laugh so hard. I love the way you said that. There's an insect on the wall. Go get a ladder.
Go get a ladder, yeah.
Okay.
What the hell is going on here?
I don't know why. I'm picturing like Looney Tunes. Like he's got to get a a ladder to just crawl up to the ceiling. Like he's not putting it up against anything. All right. Well, we've done it. So for every primitive, if it's a thing, so if we get here, we're going to have unreachable. It should be pretty obvious. We're not calling this code yet, so we're not going to hit the unreachable. If type equals pointer primitive, what is type? Type is a type pointer. Primitive is a type pointer pointer. Dereferenced primitive means we'll take away one of these, so it'll be a type pointer. So type pointer compared to type pointer, that's what we want to do, because that's how, if we go to ast.c, we say type equals, you can see that we do pointer comparisons for all these t underscore types defined up here, because they're const pointers. Okay. Okay. I am curious where we can get rid of integer literals, because currently we just don't. Okay, so type equals primitive. Okay, yeah, that's what he was saying. Currently we don't. So we have to do type equals t integer literal. Then, can we just say type equals t integer? Is that fine? I mean, it's not really gonna hurt anything. Cool. Okay, yeah. Then we'll get to t integer and it'll be good. I would say integer is probably the most common primitive type, so we should put it first. Void's probably next, and then byte. Let's go with, I feel like that's a reasonable order of things.
Agreed.
And then, I mean, honestly, they're all within the first few, so it won't matter. They're all cache locality.
I think I have tracked down the bug, but I'm confused by the fact that it exists.
You're looking for a bug while Eternal's hunting down an insect.
Looking for a bug. So I've got a function that just gives me the file location at the end of the file, because there's no tokens there to get a location for, so it just does it. Somewhere in there is a segfault.
To give you the
So what does
file
that mean?
location for the end of a file? Are you trying to say the size of a file?
Basically, so if I can say, like, if I'm expecting a token to exist, but I hit the end of file, I want to report end of file instead of the previous token.
Right.
So it's just, yeah, it's literally doing that calculation. Give me a location at the end of the file.
I see.
Why is there a segfault? P is not known. P is greater than 2.
Okay. So we've serialized types. Why does that matter? We still have to deserialize them. Okay, so assuming we can serialize types, what do we want to do now? We have a serialized module. We want to write to out, map types to offsets within type table, map symbols to types. So we have to go through map types to offsets within type table, which would mean, presumably,
Right.
so Raid, I've gotten confused again.
What?
So how we serialize types is like based on the tag, and then that gives us the value or the length or whatever, right?
Sure.
How do we okay. They all reference each other.
Mm-hmm.
So like if a pointer has a type offset that's greater, we're basically going to have to like build the type cache again, right? For deserialization.
Oh, because it's the other way around, you mean?
Yeah, you see what I'm saying?
Yeah, sure.
Because
That
we're
is-
gonna have backward. We're gonna have
Uh-huh.
yeah. I don't know. Okay, second question.
Mm-hmm.
Did you get the bug, by the way?
What?
Did you?
I'll do that later.
Okay, you and him chill, become friends.
No, he's gonna end up dead.
Cold-hearted.
Just do a comparison. I think I did a comparison back.
I have entomophobia. I despise insects. So
That's fair. They aren't that helpful. So how do we? Actual question: how do we actually find all the types that we need to put in the type table?
It just does that automatically.
Well,
Okay, very simple. Except for like if we export a type explicitly, it's going to be in some table anyway. Right?
so right.
You mean other than those, I'm assuming is what you're talking about, right?
Pretty much, as in like, where? How do what?
Export function uses a type. That type also has to be exported. Is what you're talking about, for instance.
But what do I like? How do I? What do I loop over? What types do I serialize?
Export the function. Before you can export the function, in order to export the function, you need to export its type. So you export a function type, but that requires exporting the parameter types and the return type too, and that will just work automatically.
Just recursively export types until you have all the types
parameter
exported.
types and the return types and so on. And if those structs, it has to call serialized type and its parameter types and so on.
So the module exports any type reachable from these.
Will be exported automatically.
You keep saying automatically. That's the code we're writing right now. Nothing happens automatically. Nothing's happening automatically.
Well, what I mean by that is we don't have to write code to find all types that are actually used.
We do. It just happens to be easy because all we have to do is loop over the exports.
That type of writing that code entails doing graph theory, and we don't have to do that here. We don't have to.
We're sidestepping graph theory. Don't worry about it. Just do what you're doing and it'll work.
What is this a list of? It's an unnamed struct. Of fucking course. That makes it helpful. Thanks, me. I'm a genius.
I really wish you could use unnamed structs more in C.
I don't.
But
I hate them.
I mean, if you could use them better, then I would like
that.
that.
Actually shows you what the type is instead of trying to just get its name.
That would also be helpful, yes.
Mm-hmm.
But I feel like this type's name should be this. It's kind of...
Yeah, that's not how the compiler sees it. The compiler doesn't see vector there. It just sees...
But why doesn't, like... we should have the macro expand into have a tagged struct for each vector. That's not a bad idea, actually. Put something here.
What are you going to put here?
Yeah, you have to generate a unique tag.
Oh no, we'll just... Easy. Honestly, we could probably do something cursed.
Yeah, counter is not going to help. What you could do is you could go with the old argument, this is a compiler, so you'll just use __ vector or something. That would be a unique name.
That's true. It's kind of cursed.
You can do that if you want.
It wouldn't help us.
I get around that by not having my vector be a struct.
I use vector of char twice anywhere because it would redefine the same type.
Exactly.
Obviously, the actual solution to this problem is to switch to C++, so we don't have to do any of this nonsense.
No. See, I have a solution. It's called stbds.
File API. The fuck?
That's sort of a solution, but...
It's a pretty good solution to me. You don't have unnamed structs, and you have a nice API because it's given there to you. It's great.
Well, how is that implemented without runtime overhead, though, if it's not this?
It's a pointer, and it just allocates an extra size for a header before the pointer returns to you.
Runtime overhead. Would you look at that?
I mean, yeah, but you're going to have that with a struct anyway.
Not really, because in this case, the struct doesn't need to store its type. That's known at compile time.
I'm
and
not
it should
worried
be.
about 2 extra U64s on a modern CPU.
Yeah, but that's scuffed anyway.
If
It's
it
not
works a lot
really.
better than having your unnamed structs not accessible.
Also, it depends because we have a lot of nodes that contain vectors, and that would add up if we have a large program.
Yeah, it would add up to like, I don't know, a kilobyte of data.
Probably a megabyte or more even.
Meg.
We have a lot of nodes.
What
Because
programs are
add
you
one
writing?
struct really quickly.
When do you need that many?
Oh, for a large file, I'm pretty sure
I'm
you're
sorry,
going to get a lot of nodes.
Premature optimization. I will gladly take my abstraction over worrying about such small memory.
Probably a good idea.
Yep.
It's also just generally scuffed because if you need to store a type of something that you know at compile time, then that's kind of a failure of the type system.
Not really. You're just describing reflection.
Yes, and reflection is known to be slow.
Not really.
Why would you want to use reflection if you could use static typing instead? The point of reflection is that sometimes you need to do things dynamically at runtime.
So
There you go. You just said it.
Yeah.
You just said
And what are you
sometimes you
saying
need to do things at runtime. So why not have the extra 16 bytes there? Who cares?
There's the runtime thing you needed to do that was extra.
If you don't need to do the runtime thing, you don't need the extra 16 bytes. They don't have to be included.
Why would you want to include data at runtime if you already have all
So
of the
hear
data?
me out. Where else are you going to put the data? If you're given a vector and you're allocating your AST node on the heap anyway, then the 2 fields are going on the heap with the AST node. It's either they're in the heap with the AST node or they're in the heap with the vector. They're still on the heap and it's still the same number of AST nodes.
What I'm saying is
There's no overhead in
you
this
don't need to
situation.
store the type of it because the type is known at compile time. That's the
Yeah,
point
and
of
it still is.
typing.
I do an int pointer and that's a list of int. I have compile time access to ints.
I have no idea what you're talking about then.
All right, let me show you what my code looks like because it's incredibly simple and it's fantastic.
He's gonna pull out some like Algol 68 mixed with infixed Perl. He's like, yes, I have a build script that runs this Perl and replaces it inline with its result.
No. I just do, if I want an array of token pointers, I do token pointer pointer.
That is pretty much the same thing as the vector thing that we're doing, except we're
Then there's no point not to do it.
Well, except we're using you're making an argument that it's different. This is not. This is just
No, you were making the argument that it's different by saying it was using more memory.
I was asking you whether it stores the type in the struct.
No, I said it stores the count and like the header is the 2u64 is size and count.
Well,
I didn't explicitly say it was size and count.
The type in the struct, and you said yes, it allocates an extra header.
I did not hear you say type. You said
I was talking about the types in particular.
I was never talking about the type. No.
Right.
I did not hear you talk about the type at all.
Store the size and the capacity, sure.
Yeah, and it's going to be on the heap either way, so it's exactly the same memory.
You need to pass in the type, so it knows the type.
Nope.
So for declarations,
We're writing vector of char, right? It knows it's a char, and then we don't need to store
probably do this in the same loop.
So yeah, what you're saying is that this is basically the same approach that we're taking.
Well, I'm just, putting the count and stuff in a slightly different place, but otherwise, yes. And it doesn't have to use unnamed structs, it just uses pointers.
But
Linked list gober.
Size, how do you do that?
What do you mean size?
Do
you mean the count of the vector or the size of the type?
I don't say count, I say size. Size of a data structure is how much is in it. How many elements, not the size in bytes.
Yeah, there's a function to do that. It just looks it up in the header.
Function, okay, yeah, sure. That's another option. We're using a struct for that currently.
Yeah. All I say is rlen, ARRLEN, and then boom, I have the length of the array.
Oh, I remember seeing that.
What you're saying is also that the size is allocated on the heap as well, I take it, right?
Well, yes, and that's what I was getting at, is even if you're using your vector, sure, you can put it on the stack and I can't, but almost everything that you're doing is heap allocated anyway. You
Mhm.
use the argument of putting it in an AST node, and you're heap allocating your AST nodes, are you not? So your size and count are getting heap allocated regardless. They're
Yeah,
just in
that's
a
only
slightly
one of
different
the
spot.
doing it.
We're just talking about philosophy, but for programming
And
languages
it's
now.
the thing to do, by the way. That's a pretty old trick to just pass around a pointer and allocate or put a size or something before it.
That's because he's a very old programmer still using 1990s technology, and that's fine. I don't care. It works, and it's totally fine.
Sure. Like the only thing that you can't do with this is things like small string optimization.
Which is fine. I don't care.
That's not small string optimization is a pretty good optimization though. If you
I'm not
because
using it for strings, so what am I going to optimize?
sure, well, it's also for vectors. Like for instance, LVM's small vector also puts
Let's decide what we
things
want.
locally on the stack.
Declaration.
A lot of the time because very often, at least I find myself very often I need a vector and sometimes I'll only have like 2 elements in it most of the time, but it could be more. And then you don't want to write a variant because that's annoying. So you just put it in a standard, but putting it in a standard vector isn't ideal either. So for that purpose, LVM has a small a vector with basically small string optimization where it just stores elements in the vector.
Okay.
It's small.
Are you guys using it then?
I'm using it in my compiler because I'm
Okay.
writing C++. This is C. I could we should probably do is or that's at least an option. We could vector struct. We could do smaller string optimization for this. Yeah, we could add that. I haven't because I don't like writing data structures in C.
See?
It'd be very doable though.
Yeah.
I have done small string optimization. You can look at the string header in LenserOS.
That's right.
That's small string optimization.
Mr. Mugume trying to make me nervous by pointing out the amount of viewers I have.
Hey, yo.
Rotbjorn
We're over here
says,
having an argument in front of 32 viewers. Mom and dad are angry.
I'm just sitting in the background laughing as the world burns. Molly the man says, okay, so your friend uses Python and VS Code? L friend, lol.
I have no idea what it's talking about. I'm using C-line for C++. The only thing I use VS Code for is table gen files in LLVM because for some reason there isn't a decent editor that has a good table gen mode. Even VS Code's table gen mode sucks. Like there's just no good table gen mode out there anywhere, and I'm too lazy to write one.
Sea Lion makes me shiver. That's Mr. Mugume said that. Why, Mr. Mugume? Sea Lion does kind of, it reminds me too much of VS Code to feel free.
If anything, it should remind you of Visual Studio. It's just not as bad as Visual Studio. Less scuffed, if you will. It's very different from VS Code.
So we're kind of just going to be doing this. Unless, correct me if I'm wrong. And we're going to be writing to declarations.
Okay, Mr. Mugume is saying, I don't want to touch an IntelliJ flavor after my 1 month of Java. Well, I've got bad news for you. Unfortunately, a lot of software is written in Java, and a lot of especially commercial software, unfortunately, runs on Java. So
The worst kind.
every company ever uses Java for some ungodly reason. We've had a few like presentations by uni and like every other corporation is using Java. Like everyone, everything just comes in and they're talking about how they use Java for some reason. It's either Java or PL1. So yeah, a lot of people use Java, unfortunately.
Unfortunately. Mr. Mugume, my brain connected these two and hates them both now. Ah, yes. Zario says it's bloated as any JetBrains IDE. That's fair. I mean, any IDE is by definition bloated. You use VS Code or C-Line. Neutrino, you use VS Code or C-Line. I use GNOME Builder. We are not the same. Moldy the man is confused at what I'm trying to do. I am succeeding at writing a module serialization.
Serializing, yeah. Oh yeah, now we need to actually serialize the module. We're done serializing types now. That's good.
Yeah. And this is going to be the type offset. And then we're going to write the name. Length?
Zaris is saying the only way you can use Java is with Copilot. No, that's not true. The right way to use Java is to write Kotlin instead.
Lemma.
That's the right way to use Java.
Skill issue. Declaratoins.
That you've turned me up a bit, apparently. Should I turn up my volume more?
No, I've got you. I turned you way down.
I see.
Yeah, you're good now. I figured everyone would appreciate like the arguing to happen at a lesser volume. It would be funny if I just slowly make you quieter and quieter, fade you out, yeah.
I see you've turned off line wrap. That's very nice.
Yes.
We were just talking about that while you were gone.
That's right. He was gone. Sir Aid,
I see.
guess what? I fixed my autocomplete, my completion framework.
That's good.
And now it works at different sizes.
Oh, would you look at that?
And
it's 20 lines of space in between every entry.
That's right. And I don't need line wrapping.
Good.
That was a requirement before, so
done the logical thing already and disabled line wrapping in your .emacs.
No. Here's the thing. Okay, honestly, I probably could, because at this point, I use Olivetti mode when I want line wrapping most of the time.
Yes, please disable it.
Because
it's for the good of the world.
When I'm writing like blog posts, I use Olivetti mode, and that automatically does line wrapping.
If you're writing like Markdown and you're writing text, then you can use line wrap. Then it makes sense because then you actually want the lines to wrap, because at that point you don't care about lines, you care about paragraphs.
Well, exactly.
Here you do care about lines, and it gets very confusing if you just have a line in the middle, like
this.
Around. Yeah, that's horrible because the indentation is all wrong.
It's very confusing.
Just use smart line wrapping that indents.
Implement that for Emacs and I'll use it.
Okay. And then switch to VS Code, which has it by default.
That's a fair point. All
my wrapped lines are indented twice.
Well, even if it's a fixed indent, it'll still look wrong.
Mm-hmm. It's not perfect, but it's a hell of a lot better than it being at the start of the line.
That's true.
You know how you can get even better? Just don't use line wrap.
See, but I'm not going to do that either.
Yeah, okay, sure.
So given the restriction that I'm not going to turn off line wrap, I don't think there's another solution other than get a better line wrap.
It's true.
Sure.
If a line wrap sucks, you can't turn it off, it kind of just will suck.
And that's my point, is line wrap is good enough that I'm leaving it on. I used to not use line wrap, and then I got really fucking tired of having to scroll that far or manually format. So I turned it on, and I've been much happier a programmer.
Zoom out.
Yeah, I don't want my text to be 1 point. Then it's not text, it's pixels.
How are you writing lines that long?
If you can't write code like this, are you even a real programmer?
You know, you're right, I'm not.
But if you zoom even a bit more, okay, that's a bit more.
See, but then you've also got to be like, man, I'm writing, like in Lens's case here, we're on stream. There's video compression. You can't zoom out enough and then expect the compression to not eat the text.
I'm looking at the stream right now. You need to zoom. Okay, you're already past that, but sure. Let's see. Yeah, that is still probably readable at this size. Let's see. Yeah, that is
on
still
a phone. It'd be rough.
That would be possible.
I also always
Yeah,
use multiple panels. I've got at least one, if not two, splits. So zooming out is even more of a requirement because I've got half or a quarter of my screen.
Okay,
There is an even better option.
Dapster
If you don't-
says, not sure if you saw my previous message, but I'm wondering how you prepared yourself to get into systems programming. Ha! I didn't. What were you doing before you made Light? I was making the OS.
Lenser OS, yeah.
For January through March, I was just doing the OS. That was it.
Also, like I was going to say, if you don't want to turn off line wrap, so there's a better solution to line wrap and zooming out. It's to actually break your line into multiple lines in a sensible
Oh yeah,
manner.
no, I included that in my point. Is I got tired of doing that all the time. So in my lazy, I turned on line wrap to see if I would like it, and I did.
So,
My code editor, my choice.
As usual, the best solution requires the most work that most people will probably not do. The
Yeah.
medium solution is totally scuffed and is the thing most people use, where it's like the fake indent line wrapping, like each line gets smart indented 2 tabs. It's like it's not smart, but it does still help with readability. And then there's like the who cares guy, and he just leaves line wrapping on like this and just writes code like this and pretends that it's fine.
Yeah, I don't go that far in. I've still got like 100 characters, but
That's right.
I will say the thing is also for me, I have an ultra wide, so this is less of a problem for me.
oh yeah, no, I don't. I'm programming on a 1080.
Sometimes.
When I'm in VS Code, here's a screenshot of what my VS Code looks like. The way I like to program includes a couple of extra things, like the fancy scroll bar that shows me where I am, because I'm a visual person and I can look at my function.
Oh, I used to have that in C-line, but apparently I don't currently. Interesting.
So that takes up extra real estate horizontally. Like I said, I always split my files at least 1 or 2 times. So that takes up horizontal real estate. And then depending on whether or not I have that file open, the file browser open on the left takes up even more horizontal real estate.
Sure.
Mr. Mugame. Oh, I already read that. Zaria says, my Java experience is uni courses and UML diagrams with it.
Not UML.
Mugame says, Twitch compression says, no, OSDev really is for patient people. Zaria says, or don't be verbose. Easy, kick W.
In C, I opt for verbosity at this point. All of my function names are huge.
I'm a similar way.
I suppose I can screenshot what my and I find a section of my code that is not the section where I'm generating debug info, because that's horrid.
I like your setup, Local. I honestly can't stand having anything on my screen other than code. So like file trees and like I've tried projectile and speedbar and stuff like that in Emacs, which are like the file tree you see on the left of Local's screenshot, but I just can't do it.
I don't like having it open all the time, especially because VS Code wants to jump the file to whatever file you click on in like your buffer. So
Yeah.
if I have like the very first file in the file tree open on the left and the very last on the right, it's constantly jumping up and down, and it's a pain in the ass. So whenever I'm not in the mood to look at it, I do use the find file functionality. But like I said, sometimes just visual and I want to look at things, so then I'll have it open.
For me, it's I have it open in C-line always because it feels weird not to have it open, but I don't like it in like other editors. I've tried stuff like that in Emacs and it looked weird.
Yeah, I do, and I figured out that I don't use it. It's for Emacs, most of them are made for like clicking through the file tree and like getting to different buffers in a different way. But I just like Control XB, having everything in a flat list where it's like, here's it.
And I have all my
found the perfect section of code to screenshot. Hold on.
Nice.
Hold on.
Finna Smash. Thank you so much for the follow. What a name.
There you go. Look at this.
Finna Smash. I don't know if it's a question or a compliment. What's that color theme? Ooh, that's a good question. It looks like Groovebox. Is it Groovebox Local?
I'm using one of the. It's like similar to Zeraid's. Fuck, what was it called? Monokai.
Monokai.
Mine is Monokai Pro.
Mine's just the regular Monokai.
There you go.
I see. Yeah, that makes sense.
In a smash with the heart. Aw. What a name. Also, Stainless Steel 45, Jao Russo, CIA, Dandy McGee. Thank you so much for the follows. I appreciate it. What am I?
Yeah, all my operators and everything are red. Yeah. The color theme too is very red. Like if you look at the background, it's like a very warm color theme. Anyway, this is
Yeah,
why
I do wish the default Monokai was a little bit less bright and saturated, but I don't care that much right
I
now.
like it this way.
Yeah, Monokai Pro is not as saturated. It's a little easier to read.
The regular Monokai is too much for me.
Yeah. On that note, what else do I have installed? How do you fucking change it in VS Code? I always forget.
It's quite interesting that no one is commenting on the unhinged variable names in the screenshot.
The mute and stuff.
Yep.
Yeah, I don't have access to those. I haven't set up my layers to give me Unicode. Too lazy.
I've used it. Well, I have it on my keyboard. That makes it easy for me. And also, the reason why this looks a bit weird is because it's an implementation of an algorithm that I've written out in like proper mathematical notation in my docs, because it's easier to do it that way. In this particular case, this is part of the overload resolution algorithm.
Oh, apparently this is Monokai Pro. It's just not the same looking.
Interesting.
Monokai Classic is even worse, though. Yeah, that's even brighter.
Yeah, a few things are different. Like your struct keyword is, and some of your keywords are also signed, whereas mine are all red.
It's because a lot of those I have as macros instead.
Well, macros are also red in my case.
Okay, all of my macros are signed.
Mine are red because that way they look like keywords, and I like that.
Has anyone seen this error before?
What error? Let me see.
Expected semicolon at end of declaration list.
What? Hold on. Let me see that.
I mean,
yeah,
that's a semicolon.
It's a semicolon. I think that's just a bug.
Okay. Oh, it says insert semicolon. Oh, there we go. It fixed it. It inserted a semicolon. There should be two, apparently.
Yeah, you only need one.
Wait, is that not a... Okay, I don't know.
It was just not picking it up, I think.
Weird. Okay, there we go. So now we need to write the type table offset here.
Also, what's interesting is that Monokai only has, oh god, I forgot, hold on. 6 or 7, what is it? 1, 2, 3, 4, 5, 6 colors, but a terminal typically has, no, it's not that, no. A terminal has, terminal colors typically have 2 blues, cyan and regular blue. This only has 1 shade of blue, so in the integrated terminal in C line, it uses orange for dark blue, and I'm also using the same color scheme in my terminal, so now in my terminal, the blue is actually orange.
Oh dear. Yeah, I remember you sent me your terminal color color swatch, and it was all...
Hold on. There we go.
Oh no.
There's different versions of Monokai Pro. I didn't scroll down. There's standard, which is the one that's in my screenshot. Filter machine, filter octagon, filter ristretto, filter spectrum. Those are the instances I have.
Why is there a million errors about D word?
What are you doing?
I didn't...
Why are you including Windows.h? I know why, probably. It's because of platform.c, probably, maybe?
Oh, it's just including WinNT. Why is it including WinNT?
Oh, no! That would do it.
Did I do that? Chat, did I write this?
I don't know. After you wrote it, maybe it inserted automatically. Did you, like, auto-import something?
That could be the LSP does that. It does do that.
will import it from wacky headers sometimes.
So if I did this, that did it.
That would do it. Yeah.
Okay.
Obviously, don't include WinNT directly. You're probably supposed to include Windows.h. Like you're never supposed to include any of these directly. Only
Pretty much.
Windows.h.
Yeah.
So
I don't
anyway,
think. Well, yeah. Well, you were in the middle of something.
What was I doing?
Your
Oh yeah,
mouse
I
probably.
was posting a screenshot. Hold on. Here you go. It's all
We
orange.
should have a module description.
It's all orange.
Oh no. Oh no.
Colors.
That's amazing.
The well-known orange fedora sign.
Thank you so much to Delta for joining the Discord. I appreciate it. I like that you broke Discord's rendering. That's very impressive.
Oh god, because that is not even it's like a weird triangle thingy.
Yeah, it's created out of lines and dots with continuation characters.
Oh, is it? That might be because this is what it looks
There's like
Hold on.
there's
This
like
is how
8
it looks.
bytes here.
No. This is how it renders for me. Look at that.
What are you looking at? Are you in general? Where'd you put that? Oh, gee. Yeah. Oh, so that's what's happening. It's not a line and a dot and everything. It's a Unicode triangle that's being rendered over the comma and period.
Also, because someone was asking, no, I don't use i3. I don't like tiling window managers. I just use KDE. When tried, what was it, DWM before? I didn't like it much.
Okay. Well, we did it. We should have just stayed with ASCII. I doubt it. I like UTF-8. UTF-8 actually makes sense.
UTF-8 makes sense, yes.
Everything else is kind of wacky.
Mm-hmm.
UTF-32 does make sense. It's just not efficient at all.
Yeah, there's a reason for all of them. Like UTF-8 is obviously the one you should use. UTF-32 is if you need to iterate over characters. That's like the only time I use it. I just convert to UTF-32, and because I can't be bothered writing a UTF-8 decoder or using ICU, so I just convert to UTF-32 and use that. But for storing, it's typically too verbose.
Notably, you're iterating code points. Characters could be more complex if they haven't been combined ahead of time.
Yeah, that too. Typically, I only operate on code points. But yeah, if you're iterating over like characters, if they're combined like that, even if you're doing rendering stuff, then don't do that. Use half bus. Also, don't use half bus if you can avoid it. It's also horrible. Just don't do text rendering if you can avoid it. What was I saying? Right, UTF-16. I think the only real good use case for that is that in some
in some languages it's smaller than a UTF-8 counterpart.
Kanji, I think those are typically 2 bytes, and then UTF-16 is more efficient than UTF-32 or UTF-8 or something for some of them. So I think that's the only reason to use UTF-16 really.
Yeah, CJK languages usually are more efficient in UTF-16.
Yeah, but that's about it. For everything else, it was just in general use UTF-8, and nowadays everyone is using UTF-8. Like every new protocol uses UTF-8 like this.
Except Microsoft. Microsoft refuses to let 16 die.
Do their own thing. They, for some reason, use UTF-16 and wide characters are 16 bytes, which 16 bytes. Good God, 16-bit. No, none of the. No, 16-bit is right. 16-bit, which makes WHRT utterly useless as a type cross-platform because it just isn't.
They have changed my theme. I'm going to see if I like it. It's way too saturated, but it's lots of pain.
To functions, to WinAPI functions. That's it. That's the only use case for it, really.
Why would you remove saturation from your theme? Local.
I said it was still just as saturated.
Oh, okay. I thought you were saying it's too saturated and you have to make it less so.
Yeah, this is way too.
It's too many colors, but it's pretty.
Way too magenta and cyan. This is just magenta.
Yeah, those are my favorite colors. I wish the regular words were
It's
white.
not bad.
You like
What?
magenta? Oh my god. Okay, sure.
Pink is my favorite color, and magenta is a kind of pink. I'm probably gonna go. I have one just called fucking red.
Yeah, I don't know.
But no, I want regular text to be white, so I probably won't stick to that.
What do you mean by regular text? Variables?
Just anything that's not super special. I don't want everything to be pink by default. I'd rather it be white by default and then
I see.
changed.
I typically want everything to have a color, except that in Monokai, variable names are typically white. So they're white. Everything else is a color.
Yeah, local variables, and I guess fields are usually white in Monokai as well, but parameters aren't.
Well, for me, they aren't. If you look at my screenshot, they're also purple.
All of mine are white.
Local, you were waiting for
Oh,
this?
this one's not. Waiting for what?
Waiting for what?
SegFault. Let's go.
We've got a SEGFAULT, folks.
Something is null, it would seem.
Maybe, yeah. We're getting the proper primitive.
You have integer literal. Oh, you have. Okay, good. I was gonna say.
Yeah. So we have primitive minus primitive types gets us an index. We write 1 byte and an out. We found, we break, if not found, blah. So if we get through all of them, we'll ice. We break out of the switch and we go down here. We return type record begin, in which case we're here and we keep going.
You know what? I will say local. I always thought you were using Monokai, but I wasn't sure because some of the codes are just different from how I have them.
Yeah. I switched back to Monokai when you mentioned you were using it. I was like, damn, I miss using Monokai. Because before then, I was just using the default Viz Code one.
Oh, I see. Yeah, sure. I used to use like the default Visual Studio theme was called for like a while, and I was still using Visual Studio.
Oh, okay. I changed it.
What?
I remember when WSL used to leak my IP. I had a mini panic.
Is there a reason why you're testing it in Ubuntu or?
Yeah, the SEGFAULT. I don't know where it's coming from.
So that doesn't. Am I missing something?
Yes, I'm surprised. You don't remember at this point that we don't have backtraces on Windows, MinGW.
It's on Windows that it doesn't work because you're not using MSVC. Yeah, right. I forgot. I thought there was a problem on. I keep forgetting that you're using MinGW.
Ah, good.
Are you compiling in release mode?
I don't think so.
No, in that case, this is. Have you added R dynamic to the? Let's take a look at the CMake file. Is there an R dynamic flag?
I had that exact same problem though, Lens, with Zig. I was actually trying to learn some Zig just to, be more educated on some other similar languages to what I'm trying to do with Maya.
Typically, the reason for this is that these functions are static, and if they're static, it doesn't export the name.
Rude.
In my experience, that's typically the problem. So if you make them not static, you might see the name.
I don't know what, but write bytes is static, and we do see its name.
And the only function it's calling is vector append, though.
So it's doing its job, it would seem. I don't know what is happening then.
So we've got a SEGFAULT and no idea why or where it's happening. Fantastic.
The only place that makes sense is in vector append, though, right? Because if there's a function call after write bytes, and that's the only function there.
Because we've been using vectors all over the code base. If vector append was broken, we'd have noticed that a long time ago.
Symbols wouldn't work.
If you're not initializing the vector, that would be an option. Are you initializing the vector, wherever it is?
What vector?
You are using a vector, aren't you?
What vector? I'm using a million vectors. What are you talking about?
Like all of them. Every vector you're using.
Well, yes, they're all zero initialized.
Good. That's good. Good. Because I forget that sometimes and then bad things happen. In that case, I think my next suggestion would be to use a debugger and just...
It's stupid Visual Studio time. I hate it.
I would say use CLine, but it's not free, so
Yeah, if you pay for it, yes. For a
I
low,
don't.
I'm saying if you pay for mine, I'll use it.
Oh, I see. No, I won't. That is.
With the same vehemency. Is that a word? What am I trying to say? Intensity. That's probably better.
The intensity.
All right, everybody stand up and stretch. It's been like
I'm
2 hours.
totally- Yes, I'm
Fine.
putting my AC.
I can, I'll stand up.
So I am
I'm proud of you.
standing.
I'll use my standing desk. How about that?
Hey, that's even better than I can do. Sorry, everybody. Just opening Visual Studio takes 10 minutes because Windows is a piece of crap.
Uh-huh.
We'll just wait for that. Do some stretches. Drink water if you have any.
Oh, that's a good idea. I can't believe you haven't cracked your Windows to get rid of the activate Windows text.
That would be illegal.
Yes.
We don't do illegal activities here.
For legal reasons, we don't. For practical reasons, they don't need to know.
The real, like, if you're under 18, just say you're over.
Yeah.
Yes.
Like everyone when they signed up for Club Penguin.
I miss Club Penguin.
I do too.
I still don't know what Club Penguin is.
What the fuck?
I can't believe the world's so large that, like, something that everybody I knew knows about and, like, played just is, like, gone to some people. They don't even know about it.
Yeah, well, most people don't know Laurel and Hardy anymore either.
That's true.
Oh, Bud Spencer and Terrence Hill, how about that?
Yeah, but they're not Club Penguin.
Yeah, I don't know what Club Penguin is.
That's
okay?
the problem.
Penguin.
You're getting our point. You're understanding. What about RuneScape?
Oh.
Everybody knows what RuneScape is, right?
Yes, I do know what RuneScape is.
All right. Well, Club Penguin was bigger than RuneScape for a bit.
Oh, yeah.
I loved doing the secret agent stuff. I felt so special, even though everybody was doing the secret agent stuff.
But nobody knows.
Secret.
Well, this is nice. Oh my God.
That's not
agrees.
what this
I'm
file
trying
looks like. What?
Seal my window because the Windows seal, as I already mentioned,
Have
is
you
just-
rebuilt for your Win32 CMake project?
Yeah. That's
So I
what
know you
this
did that for
does.
MinGW and WSL, but have you rebuilt this one?
Yeah, it's just not. It's giving me the same error, but this is in a C file. This isn't. This doesn't need to be constant.
What are you doing? Hold on. What do you mean it doesn't-
MSVC sucks.
Expression must have constant value.
What is
Oh,
this
I-
meant to be?
It's not. That is not const, by the way. That's a const. Oh, is it this const pointer? Ah, it's a. It probably is. It is probably trying to tell you that you need a constant expression.
Yeah.
Even though I don't think you actually do in this case.
Right. It's
No.
just a. What? MSVC. What is this then? Ah.
Yeah, this isn't a constant
Yeah, but it's
expression,
not an array.
but it's fine. This is like a.
It
weird
doesn't
part
compile.
which is static initialization. It sucks.
It doesn't
Sucks.
compile. What do I do? This
Doesn't
is.
compile. Oh, MSVC just rejects it. Yeah, delete that array. You can't do that. Is the answer. You just can't do that.
What's this? What's the alternative?
The alternative is you allocate the array beforehand, then fill it in main.
MSVC sucks.
Yes, I keep saying that. MSVC sucks. We should just all use Clang or
I'm using
GC.
Clang.
Not
Pretty
worry
sure.
with supporting MSVC.
I like Clang.
Well, we can't find the solution to this seg fault. What's your guys' idea? Oh yeah, don't support MSVC. We can't find the seg fault then.
Alright, you need to update Visual Studio to be able to install ClientCL, but your drive is full, so you've ordered a new drive in order to copy your data over so you can remove some from your machine so you can install ClientCL so this all ends.
Cool, I'll just
Yeah.
do it next week then when that shows up.
Just
Fuck's
remove
sake.
the initializer for that array, allocate an array of 4 type pointers. That is
Just initialize it in main.
This is the stupidest thing.
It is.
It is stupid. I keep telling you, MSVC is stupid.
It's not MSVC, it's C's fault for not having a solution to this.
It's also stupid. Everything software sucks.
I agree.
Software sucks.
Why can't so I literally have to just do this? This is so stupid.
It is. I mean, you can still do the literal, right? Can you?
I can't. How can I do a literal?
Problem.
Well, not here. No, in main. Can you not initialize with the literal in main? I don't remember when you're allowed to use the literal for arrays.
You can do that. Yes, I'm pretty sure you can do that. But you might.
That's gonna create a whole. Yeah, that's not. That's gonna create a whole local copy, and then it's gonna be the whole L value. I can't do that
This
for.
one fine, don't do that.
Yeah. No, this isn't a struct. If it were a struct, you could make a struct literal, but I don't think there is an array literal.
Yep.
You can try.
That's what I keep forgetting. Oh well.
Soft language.
I love that half of this Serrate is far away.
Any updates? That's why. That's what
Just running around his room, still looking for the bug, complaining about C.
The bug. I'm currently trying to seal my window because
Oh, that too.
He's got his cock out
He's whipping his cock out.
to seal the window.
I don't know if that's sealing enough. What's in your diet?
No. Silicone.
Okay, I think I'm more or less going.
Okay, well that's the stupidest thing I've ever done.
Yes, that is the stupid. Funnily enough, you can leave out the last one because it's 0 initialized.
I don't trust that it's 0 initialized.
It is 0 initialized. That you can trust.
I cannot.
That's stupid.
Where I don't know how I'm gonna declare this yet. Even
Global variables are
You
0.
can still declare it as a whatever. You just can't initialize it.
There's an array with size 4. Just leave it empty.
So
Yeah,
just
fine.
do what we did before.
Sure, you can put it here. That works. You can also put it in some other. It has to be in somewhere. It doesn't matter where it is, but that works.
Yeah,
Sure.
I was just gonna say leave it where it was before, but without the initializer.
Yeah, that's what I would have done probably.
I mean that's just randomly an AST.C.
Okay, wherever you want. That's fine.
If this is too loud, by the way, just tell me, okay?
Okay, it's exciting.
Is this too loud?
It's
Don't hear
silence.
anything.
You can't hear it. Good.
Fantastic.
It's
The
very loud.
silence is overwhelming. Turn it down.
I already have Lens. I have you in 200%. Oh god. Oh god, your audio.
What have I done?
I don't know. I have you on 200%. That's
You
all I
sound
know.
the same to me. Nothing changed.
Okay. We'll see.
We'll see.
I guess I'll have to use headphones. All right.
I ca-
Plug in headphones.
Rip. I hit my head this morning when I was plugging in my headphones.
Oh. Well, that's good.
Let's see here. Okay.
You were right.
I told you it was the vector append.
How?
I don't know why it is, but it is.
It doesn't
There
make
we
any
go.
sense though.
What doesn't make sense?
That
I
the
don't know
vector
what-
append is crashing.
Vector append is crashing. Why?
But it's not.
It's because it's a read from somewhere. I still don't know where. You're gonna have to go up the call trace. But
What? Okay, hold on. Oh god.
Why are you mad?
why you have to be mad?
What is happening? Hold on.
This is fine. So we have declaration.
Yeah, it has a capacity of 16. That is probably fine then. No declaration name size.
Why are you referencing size?
Because we have to write the name size, the name length.
Yeah, we need to write that. That makes sense.
Oh. Well, no, that shouldn't matter.
Your size of wrong? Shouldn't it be size of ref?
What?
Don't you need to get the address of in the size of as well? Because that's what you're
No,
passing in.
no. You need to.
No?
No.
You.
Oh, yeah, no, that makes sense. Never mind.
Yes.
4.
What? Why is it crashing? What is null? Out is null. Look at that. Out is null.
What are you talking about?
Look in the window. Out is null.
Yeah.
Oh, yeah, because that's 0. Yeah, we haven't written to it yet.
It has to. Okay.
That's fine.
Yeah.
We're not writing to out.
Yeah. We're not writing to out. Writing declarations. What is declarations? Is not null. Okay. How much are we tending to write to it? 8 bytes apparently, so that should work.
We haven't written any bytes because the size is 0.
So the first write failed.
What?
Because the size was 0, the first write must have failed.
Yeah, that is weird.
Yeah, so it's failing on the first write to declarations.
Why is that? We're appending v to out. What does vector append do? Let's take a look at that. Maybe it doesn't work with a span. It should work with a span though.
It's fine.
No, here we have a string buffer. That's slightly different. Let's take a look at vector append. So we reserve from.size, that should work, and then we mem copy into 2 data equals 2 size from.data from.size times size of the element size. And then we append the size. Yeah, that should work. That should work. What you can try is inline the macro.
Yeah, we could just expand it.
Yeah.
So why is this failing, though? This doesn't make any sense.
It doesn't make sense. I thought I'm missing something.
Oh my god, I'm an idiot.
What is it?
It was an and. A single. Yeah, wow. Hurrah. Fucking surprising. God damn it. I'm an idiot.
Yeah, well, reinterpreting type offset, which at that point is probably 0 as a pointer, would probably do that. Yep. That is a good point.
This is exactly the issue with the cast and changing the underlying type.
Yes, that is the issue. Yes, very, very much. That is the problem with type with casts.
Okay.
That has nothing to do with integers. This is you're casting an integer to a pointer or at the opposite one.
Which should be a warning.
Yeah.
Well, a Wconversion warning, right?
That you would ignore anyway.
Yeah.
This is why C++ has 3 types, 4 types of casts. And even that wouldn't help you, funnily enough.
Nope. So there's no reason to switch. Let's go.
Look at how terrible the semantics are for integer literals in C.
Yeah, the ints.
That's stupid.
Guess what type char literals are?
Int.
Yeah, they're also int. Only in C. In C++ the chars. In C the ints.
Mr. Mugame said, how can people mesmerize all of those Emacs or Vim commands?
I'm not sure what mesmerizing.
I use a little stopwatch and I swing it back and forth in front of the command, and then I say, you will be mesmerized. It works well. What's your technique?
I just use the macro mesmerize.
My technique is very simple. It's called not using Vim.
Ah, yes, naturally.
The command line, but rarely. And then if I need to edit something on the command line, which is Emacs in the terminal is scuffed.
Yeah, it's not.
Vim for that, but I'm not good at it.
Emacs in the terminal isn't scuffed. It's just not the same as not the same as GUI.
I found it to be a bit weird, and also you can't just type in Emacs. You have to type in this entire thing with like -n or whatever it is. I don't even remember.
Right. Yeah. Pretty sure he meant memorize, lol. In that case,
Really? You think?
memorize. How do you memorize all the Emacs commands? So I remember when I first started, I got a similar frustration where I was like, there's too many buttons. This is stupid. I just want to use the arrow keys. Fuck this. And then like a week later, I was like, I was using the arrow keys and I'm like, this is so slow. This is so dumb. I want to use those keys again. That sucked. And then I wrote a text file that looked like this. And I just kept writing lines like this. And I said, previous line. And then I figured out like all the ones I need.
I see.
Forward character, you know what I mean? And I just kind of went through and said, okay, these are the actual binds that I use and need to get around. Figuring. Go ahead.
Keep going.
I was gonna.
Okay, yeah, you talk.
The delay. So the biggest thing was control space, figuring out mark region. Because like you just set a mark and then you move from there, and then you have your cursor and your mark.
Well, I was gonna say, I don't really use Emacs much these days, but I'm used to Emacs key bindings. So I keep constantly closing windows on accident.
Oh yeah.
Cut on Emacs's Control W. It's also and the copy is Alt W, but for insert I use Shift Insert.
You don't use Control Y? You don't yank it?
No.
Survey doesn't yank.
No, because the problem is I can't press Control Y with one hand. I can press Shift Insert with one hand.
What do you have, tiny hands?
You use right shift?
I
I pretend that key doesn't exist.
I can do it with one hand, but it's like straining. I need to stretch my hand. It hurts.
I don't have to stretch my hand at all. You have really tiny hands.
No, he has webbed fingers.
My caps lock is my control, so it's much less of a distance there.
Oh yeah, well if it's caps lock, then that's easy.
Yeah.
That's very easy.
Yeah, it's so much easier.
That is extremely easy then.
Just do that.
No, I'm used to control being controlled. Caps lock being controlled is weird.
Well, see, just don't use caps lock and have both controls. Both of those are control for me. So if I want to copy, I use if I want to copy or paste, I use Control C and Control V with the regular control. But anything higher on the keyboard, I use the higher control. Or if I'm playing a video game, it's so much more comfortable with WASD to have the control there instead of all the way at the bottom. So I've gotten so used to double control.
I'm so used to pressing control with my pinky. It would be weird to press it with my ring finger if I'm on WASD.
Well, I still use my pinky, yeah, because I have my ring finger on A.
So here's the thing, Saraid, you would hate my key map. The caps lock button to the left of A, if I press it, it's backspace. If I hold it, it's control. And if I double press it, it's holding backspace.
Of course it is.
It actually is great. I never move my hands. Because doing all of this, my hands are not moving off home row.
I see.
Which is fantastic. And then I can get rid of things. And then I have delete right here too. So I can delete forward, which I didn't know was a thing until Saraid taught me.
Didn't know what that
delete forward.
So I thought backspace and delete did the same thing.
Yeah,
oh my god.
Good God.
How would I mean, I just never would press delete. It's on the other side of the keyboard.
I learned what delete does when I was 6.
To me,
how do you know what delete is?
So what video game binds delete?
None.
Exactly.
Yeah, but if they bound delete, it wouldn't be for deleting forward, so it wouldn't teach you anything.
I delete words or letters all the time in everything where you need to enter text.
I didn't know what page up or page down did for a long time.
Those are less useful than delete. Page up and page down are less useful than delete.
I don't use delete that often anymore either. I just I control arrow keys everywhere, and so I'll select a region of text and hit either delete or backspace, whichever is closer. But I don't explicitly delete forward a single character nearly as often anymore.
Well, I use control to delete a word most of the time.
I should probably use Control Delete a lot more because, like I said, what I do is I just Control Shift to the end and then either delete or backspace, whichever feels right.
I
But
Alt
at that
D.
point, when you're selecting text,
Wait, Alt D does the same thing as Control Delete. I use Alt D.
not for me, it doesn't. Not in VS Code.
I have no idea what Alt D does.
It deletes a
You
word
said
just like Control Delete.
It
Look.
does. Interesting.
Yeah.
It's an Emacs
Doesn't for
thing.
me. Yeah.
It's an Emacs thing. Control Delete works in most editors.
Yeah, it's kill word.
Also, funny, Shift Insert is a very old hockey. It predates
Yep.
Control D. So
Yep.
Shift Insert also works just almost everywhere. So I use that almost everywhere.
I don't think I can hit Shift Insert on my key map. Because I'd have to hold... Yeah, I couldn't.
On your keyboard?
I have it on a separate layer that I need to hold a button down to get to, but the button I need to hold to get to that layer is right next to Shift, so I'd have to like use one finger to like mash 3 buttons.
I have the same problem on my laptop. I'm pretty sure I can't press Shift Insert on my laptop. So on my laptop, I'd use Control Y because I can't press Shift Insert. Because Insert is the Shift state of delete on my laptop, I think. So I physically can't press Shift Insert, and it sucks. Then again, programming on a laptop sucks, so...
That's fair.
It does, yes. I hate laptop keyboards.
If
If you get a good laptop keyboard, then the laptop's too big.
And that defeats the point of a laptop.
Yes.
Hey, that's perfect. We have something, Saraid.
Do it? Would you like stuff in there?
We have a lot of zeros, and I'm very scared.
Oh no, that's normal.
That's normal?
It's just like 7 bytes are unused.
Yeah, I mean, if you're writing an entire U64 that's only the value 7, then yeah, it's going to have 7 null bytes.
That's common.
Okay.
That's why things like LVM bitcode is bitcode, not bytecode. It encodes things in. It uses like groups of 3 bits or something to represent integers.
A lot of space savings, but it takes you longer to encode and decode it.
Yeah, that's not the problem. It takes longer to decode.
Someone was asking about my keyboard, if it's a split keyboard or what. It is a split keyboard right down the middle here. So these are 2 halves.
Oh, if we're posting keyboard layouts.
Oh no. What have I done?
Oh no, yeah. I'm gonna post mine again. Hold
I
on.
can post mine. It's just going to be a screenshot of your standard US keyboard layout, but
This is mine.
104, 88?
There we go.
104. I've got a full
Nice. Ooh, yes.
Mine in general.
Yeah, this beautiful thing. Oh dear.
8 layers.
I don't know how you even use it.
How I use it is very simple. I've remapped the menu key to be my 5th level modifier. So I press menu to access the 5th level, menu shift for the 6th, menu alt graphic for the 7th, and menu alt graphic shift for the 8th.
Naturally.
Which this is useful because I have pretty much almost, not exactly, but almost the entire IPA on the keyboard. And so like critics like
that, but
combining dot below and combining dot above, I've been using that very often recently because for reasons that shall not be revealed yet.
Why am I doing this?
Yeah. You'll find out what that's about in the next Agma Schwa video, probably.
Hey.
I forgot what I was doing. We got so sidetracked.
We were existing.
I'm over here trying to do lie at the same time that you're trying to do intercept, and it's getting my brain all confused.
You ever wake up out of whack?
Always.
Go ahead, Saraid.
I was gonna say, I've recently implemented defer in my compiler. Well, a very basic form of defer that currently requires removing break and continue, because adding that back in is going to be a bit more complicated, especially multi-level break continue with defer.
I don't know how exactly I'm going to do it. I have a couple of ideas for really naive implementations that would just be like absurd. but
Why? Okay.
Sky. I'm not sure how to pronounce that. Like, I'm gonna go with Sky Xar for now. I'm not sure what to make of the C in there, but on my Discord, on my I can't talk today. On the Discord, they mentioned my setup, and yeah, it took a while to get that to work, and I've no idea how to do that on Windows. By the way, or if you can even make an 8-layer keyboard on Windows. This works on. Oh, I suppose it could be a compound of that. Yeah, you're true. Yeah. I didn't. That is an option. Yeah.
Sky's
Zar. Yeah, it could be Zar. That makes sense. But yeah, as I was saying, figuring out how to create this thing took a bit because it's a bit cursed. Where you have to. It's somewhere on my GitHub, I think. But yeah.
I won't get to my defer implementation for a while, though. I'm still refactoring my parser again.
My parcel is mostly done in terms of no more refactoring. So
this quote unquote should be the last refactor I have to do.
I've said that before.
I'm gonna try to hold myself to this is the last one. But we'll see how that goes.
I'm just not smart.
It's also probably the like 10th, if not 20th attempt to write this line, to like write a compiler for this language, and this time it's actually working. So
yeah, that's where I'm at as well. Except I've also trashed working implementations because I didn't like them.
I see.
But also, to be fair, they were bad. The most recent working one was in C#, and it was binding to LLVM through some other library that just like doesn't give you all that much access.
That's annoying. Yeah, it probably was using like LVMC API, which isn't that.
Yep, it was generated from the C API into C#.
Yeah, I know the problem. It's just I've used the LVMC API before. It works.
So while
you have to use it by using SQL API, much better.
You had to use it so carefully, and you couldn't get any internal information out of it. So my debugging was just trial and error.
Yeah. That's not how you can feasibly use. So what I found is the best way to use LVM if you want to be able to debug it to some extent is. I've talked about this before, but it's obviously not compiling in debug mode. That is nonsense. That is insane.
No, you'll never get that.
That's a 2 GB library that you get. It takes a minute to start the debugger to load that library. A minute. And recompiling also and linking also takes half a minute. And when you compile it, I hope you have at least 60 GB of RAM, and you have to set a compile flag to limit the number of parallel link jobs. Otherwise, the linker will start swapping. So yeah, compiling it in debug mode is horrid. Working with it in debug mode I haven't found a good way of doing it. So yeah, don't do that. Instead, compile in release mode, but with assertions enabled and with dump enabled. That way you can just print out anything and you just see what it thinks it is. And together with a graphical debugger, you can actually debug LLVM that way. It works fairly well, especially also since a lot of the things that you're going to be calling are typically implemented in headers. Not all of it, obviously. It will still call out to compiled code, but you can at least step in one level or two, and most of the time that's enough. Most of the time that's enough. And for cases where it isn't, you can look at the source code. That's last resort. That also helps sometimes. But typically, debugging LLVM works if you're sort of familiar with how it works internally.
By the end of using that library, I kind of understood LLVM a little too well for just a C API. Not enough, but
Kaiser plus Czar. Kaiser. Ah, nice.
Yeah.
Does anybody know how to hex dump the contents of a section in an object file?
Object dump thing.
What object dump? How? I can't remember.
T something. I think it
T?
was T. Object dump. Object dump -S-J followed by the section name.
I tried that. It didn't work.
Right. -S-J followed by the section name. Well, you probably misspelled it.
I didn't put the stupid object file.
That would also do it. That would probably also do it. Yeah.
See, I just
The only
kept
way-
reading this one.
The only, yeah, that's you should read all of the errors, starting at the top, preferably.
I didn't know
That's
that was
just-
an error. I thought that was the call.
Yeah, well, that's what the shell prompt is for. So you find the top.
They're all the same color.
No, it's a darker gray.
That's a darker gray. That's very noticeably a darker gray.
Oh, it
what was I
is.
saying? The only reason, by the way, why I know that how this command works is because it's in my shell history. Because I've done this before for when I recently implemented this in my compiler.
Is there a quote?
Just happens to be.
That just happens to be a character.
It's probably
it's-
the 22.
It's just a 22. Why is that? Okay.
It's gonna
Well, that
render
makes
a character
sense.
if there's any character code,
And then
a dot or something else if there's not, and that's it.
Printable, it prints it. If otherwise, it's a dot.
okay. Lens gray is
Gray
gray.
is gray.
It's all gray. Okay,
The opposite
well.
of seeing in black and white is you only see things at the exact same brightness.
Everything's gray. Well, we've written a serialization function. How do we know it works?
By trying
Writing
to
a deserialization function.
exactly, it's running deserializer. That's the only way.
What do we?
The other pain.
I would be here for 4 more hours.
What do we deserialize into? A list of nodes?
Okay, so this is an interesting question. What I would deserialize into is a module, which we currently don't have. So an AST struct. We create a new AST struct, and that's the result of deserializing a module. And
I
all of
assume
the
you just get a bunch of declarations.
yeah, you get all the types are turned into like actual type structs, and all of the declarations are turned into AST nodes. So you deserialize it as AST nodes, and the entire thing goes into an AST. And this should probably return. This can just return an AST point, honestly.
Okay.
This can just return the thing, yeah. And take in a string or a vector of char, whatever you want to do. But a string works, sure.
String.
Why is it-
String.
It could also just be a span here because we don't need to modify it.
Yeah, it could.
There's different ways of doing it. We could also save the string and use spans to refer to its contents. There's like many ways of doing this. And yeah, we really should rename the AST struct to module at some point. I can maybe do that in C line because it's probably faster if you can use OSP to do that.
Yeah, we'll be fine. We'll get there eventually. That's a good small PR though.
Yeah.
I'm
So
intending to leave my AST struct called AST and just have like a symbol table be my module instead, but I don't know if that's a good idea yet.
Sure. The thing is, the AST struct is really already sort of a module struct in this compiler. That's why this works.
Right.
Because like the string table, I'm pretty sure is in there as well, and everything else.
yeah.
Yeah, the way I'm setting this up, I'm still questioning whether or not I'm going to try to parse C header files rather than call out to another library. In which case, I would have 2 different kinds of languages compiling to the same module, so I want 2 separate ASTs with the same internal module structure.
balls.
My recommendation would be to call into Clang or something
I
else.
probably still will, and either way, if I can, I want to transform it into that module structure.
Sure.
But I'm a
Well,
masochist, so I kind of want to parse it.
Well, you can. Okay, there's 2 things to this. Sure, you can pass it yourself. But I mean, we'll get to that in a sec. But you can just use Clang and get the declaration and get data about the declarations that you
I'm gonna
need.
parse those.
You can just walk the AST and just convert it over.
So that's
The
what
only
I'll
problem,
probably
the
do.
only problem is that sure, parsing C sounds fun until you need to parse Windows.h and deal with all the MSVC built-ins.
Yeah.
Yeah. Try
The
it.
intent was don't do that, but I can't stop people from doing that, so I'm probably going to end up on Clang.
Windows.h is the main reason why I wouldn't do that and stuff like that. If you just want to, even like, thing is, okay, even parsing regular C headers, like if you're parsing glibc and it asks you to call into built-in VA list tag decal. Yeah, okay, you need to implement all the compiler built-ins that GCC has, or that GCC uses for glibc, and there's a lot of them, and all the attributes. Like, because there's a bunch of stuff in there that's like standard library code especially uses compiler extensions heavily. And you'll have to support all of those, and you have to know all of those work if you want to pass it properly. Because you can't just not do that. That's the problem. Because even you need to implement all of C too. Even stuff like weird stuff like what is it? Flexible array members at the end of a struct. Because you might think, okay, you don't need those. Whoever uses those, try using like stb image. They use those, for instance. Yeah. So you have to implement everything, and just implementing half of C doesn't work if there's some obscure feature that you never use that you don't think anyone would ever use. Well, it's probably somewhere in glibc and the 1 million lines of code you end up including. And Windows.h itself is also just a nightmare because of all the MSVC extensions and like 32-bit pointers and 64-bit mode and stuff like that. So yeah, I would strongly recommend against writing a C parser or even compiler if you're just planning, if you're not actually planning on writing a new C compiler that can like compete with Clang and GCC or MSVC and compile all of C. If that's not your intent, then just for writing a compiler for a different language, I'd argue it's better to call out into an existing implementation of that.
So how do I do that with Clang then? I haven't actually looked for it yet.
So what you can do is you can actually see sort of an example of how a bit of that works in Intercept, because we have that format check plugin, which is a Clang plugin, which is called into by Clang. That's the other way around. But it goes at one point iterate over the AST. So how AST iterations in Clang works, you can see that in there. We can maybe show that real quick if Lens wants to.
What are you? I'm so sorry. What?
We were talking about iterating over an AST in Clang. So you could
Oh
maybe
yeah,
show
yeah.
the plugin real quick.
The format check plugin?
We have a Clang plugin to type check our custom format strings.
Is it format check plugin.cc?
Yeah, this thing here. So here at the beginning, this run function here, it works over inheritance, everything in Clang. But this basically iterates over AST mode. So this is part of matched AST nodes, and we're getting a string literal out of there and everything. The Clang AST is a bit. There's this saying in Clang, like the Clang AST is neither abstract nor syntax nor tree. Sometimes, but you can see some of the stuff of how it works in here. If you need help with that, I can also give you some tips of how that works. But in general, what you do is you'd call into libtooling, I think it's called, to pass the header, and then you can get the AST from that, and then you can either iterate over the AST, or you can use AST matches, which if we look for that real quick, there should be some
A matcher.
Yeah, here we are matching call expressions, collies of which are function decals, and we're binding those to the name func and binding the call itself to the name call, and then we are running a matcher on that, and it calls back in our match finder and gives us all the function decals, basically, or all the function decals that are actually called, all the calls and functions that are called by them. And that's all the way up. If you go back all the way at the top, we should see, I don't remember how I did it in here, but yeah, you can see get node as function decal func. So here we're getting it back out. What you could do is you could just match all the decals, get all the decals, and then convert them to your format. So that is something you could do. That's one way of doing it.
Yeah, I'll get to that eventually.
You could also just ask it to find, like, if you want to do template instantiation, you can ask it to find one specific thing. If you want to do, I mean, you're using C in that case, so that's not going to be a problem. But if
I'm not intending to also support C++ because of other shenanigans, but if I find a way to, then maybe.
Because then you also have to do with like constructors and destructors and all of that. But if you want to search specifics for a specific symbol, then that also works. That's also an option. Or even if you need access to the preprocessor, I mean, you don't.
No, I just need the result of the preprocessed file. I just need declarations and like types and stuff, and then I can do my best to convert types.
Yeah. But what you could do, for instance, if you could define __lie_c in as a macro if you need to use that for some reason when you're passing headers.
I shouldn't, but good point.
Yeah, so stuff like that is also fairly simple. We are doing that actually in the format check plugin. I'm defining __ ext format something, so that if the plugin is enabled, it uses an attribute. Otherwise, it doesn't.
Right. Cool. I will keep that in mind for eventually, after the parser refactor. It's turning more into a rewrite because I changed the data structure so significantly that things just don't work, and I'd have to spend like 5 weeks refactoring anyway.
What did you change about it?
I changed enough of the data structures that almost none of the code works correctly anymore. I'd have to go change like every single line of code individually for like 5,000 lines.
In the AST data structure, probably.
Yeah.
Or...
Yeah, all of my nodes. I changed the tokens just a little bit, so the lexer only had to be changed for like 5 minutes. But the AST, I didn't like the way that I was doing it before, so I've reworked it.
No, it's like, yeah, I know what you're talking about. I've tried to do some refactors, and so what I tried doing originally, I thought it would be nice to separate, because in my compiler, everything is a tree, like types too. Types and expressions have the same basic node type.
Yeah,
That's also
same.
because types can be expressions in this compiler, and expressions need to be treated as types sometimes. So it has to be the same thing. I tried separating them once, but it just didn't work. So
I only separate really small things. Like I've got the concept of a modifier keyword, like your export or your inline or no return. I'm using no return as a keyword instead of a type. I don't know if I'll keep that. But like I've got that data as a separate struct, and then I just keep a list of those inside the AST node itself.
yeah,
Or a variant in an enum has its name and its fields, and that's a separate struct that gets bundled into the AST as well. So I have a handful of things I pull out, but most of it's in the shared AST node, types included.
yeah. For me, the big node thing is currently a variant, which will probably, if I mean, the thing is, this is only, I'm planning to make this self-hosted eventually. It's less of a thing for you because your language, I think, is more C-like, so it's
Very.
so yeah, you can probably just eventually reuse the
Uh-oh.
same code base and call that self-hosting. But in my
It's not that C-like, no. I could probably, since I do want to support, like I said, bringing in C header files, I could probably start rewriting it a couple functions at a time and start, keep referencing the old C code with little to no change. But I don't know that I will.
yeah, that's harder to do for me because I'm using C++, and
Yep.
because of I like using templates a lot, so that would be, I'd have to, I'd probably want to support instantiating C++ templates at some point anyway, because that would make it possible for me to reuse a lot of code, because the main problem is if you're writing a new language, especially if it's one that I want to use like or instead of C++, I can't. There's so much useful C++ code out there. You don't just want to throw all of that away because you don't want to re-implement all of that. You want to be able to use that if possibly. And C APIs, sure, that's an option. A lot of libraries have good C APIs, but it's not the same as using a C++ API where you can inline the template and everything. That makes a difference in some cases. So ideally, I'd want to be able to just instantiate C++ templates. But yeah, but I'm still wondering whether, because there's a refactor that needs to be done and that I will do when I rewrite this in my language, which has much nicer support for variants than C++. But currently, a tree is 400 bytes because it's a variant and everything is just in the thing.
Yep.
So if you need a lot of those, that can get a bit annoying. So what I recently did is I added like a memory allocation profile that just kind of checks how many trees have been allocated. And currently I'm not compiling very large programs, but the question is whether programs will get so large that compiling them with this compiler will be unwieldy because of how big a tree is, or rather the question is whether that will happen before or after I've self-hosted it. Because if it happens before it, I will have to change it to be some more like Klang's AST, which is inheritance based. And the thing is that the only good way to keep the size of things small if you do is you doing something like inheritance, because that way a number is just one thing and a struct can be 50 things. But currently, even a single integer literal node has all the things in it that a struct would have. In
I
a union,
mean,
admittedly, but still.
why not unions?
It is a union currently. A variant is just a fancy union.
Right.
It is.
But like in my case, if I have a type, sure, it's the same size as maybe the biggest struct. But if that's what you're referring to, is it's the same size as the biggest struct, yes.
Yeah, that's the
But
main problem.
but at least you're not having like 3 structs sequentially adding up together. It's still
No,
just
no,
the size of
yeah,
the biggest.
union, but that's big enough because my structs are my type. I have type struct, which is my structure type struct. Like that's also, it's horrible to talk about that because you end up using type and struct all the time.
Yeah.
It's a struct, it's a struct, a C++ struct called type struct that implements structs. This is
Yep.
horrible to talk about this thing. It's 264 bytes. I think that's the largest one.
That's big.
Oh, the largest one is a template deck, which derives from that. So that's 312 bytes. And the template deck needs 312 bytes, but an integer literal doesn't.
Yep.
So if I allocate too many of these, I have a horrendous memory usage problem. And the question is whether that will happen before I self-host it or after. If it happens before, I'll have to change it because I won't be able to compile programs then. Either because it takes too long or because I just use too much memory.
Or just write smaller code. Make your self-hosted as small as possible.
Yeah.
Code golf your first self-host, and then you can expand it with the self-hosted.
Thing is also though that the way I plan on doing modules, you sort of have to keep an entire module in memory at one point. Like if a module is split across 20 files, you have to kind of parse and semma all of those at the same time. Like parse all of those, concatenate them together into one giant AST, and then semma the AST all at once. Because this language, that's how this language works, because it doesn't have forward declarations or anything. And because of this, the syntax is so ambiguous that you can't even tell if something is a typo or whatever it is actually without doing semantic analysis. Like a template instantiation, a function call, and a struct literal look exactly the same. You have no idea which one it is until you've done type checking.
Yep. Ideally, I get to the point where I can just free all of the memory from a front end by the time it generates the correct intermediate representation. I'm not there yet because I'm still kind of relying on tokens. So I'd need to just start copying strings and locations out of tokens instead.
Mm-hmm.
So then hopefully by the time I'm done semantic analysis on a module, which a same problem because there's no forward declarations, it's out of order declarations on multiple files. By the time I'm done with the module and I've generated the IR, it should be able to just remove all of the syntactic information that came with the AST and only keep its copies, which should be much smaller.
Yeah, cross module, that's definitely a good idea. What I'm probably you can just throw away function bodies, for instance, at some point, because you still need the declarations.
Yeah, and the
But
declarations are going to have the code in them because I'm at that point I haven't compiled them to an object yet. So
yeah,
we'll figure out when that gets discarded if it does at all, but it should be smaller than the AST.
I could, for instance, throw away function bodies after codegen because I have the IR at that point, and I only
Exactly,
need
yeah.
the signatures. So yeah, that's definitely an option. Or just because the thing is also that I would like to make my tree type ref counted because that would get around the problem that I kind of trees are part of the module, and I can't just make a new tree without having a reference to the module because they need to be stored somewhere. And they can't be unique pointers because the same tree may be referenced in multiple places. I don't want to make it a shared pointer because shared pointer has a fuck ton of overhead for just reference counting. Shared pointer is not just a reference count, it's a lot more than that. So yeah, I don't think I want to use shared. I could try, but I don't think I want to use SharePoint. And so far, my attempts at making it reference counted haven't worked too well because of complicated reasons. That last time I tried it, it would have involved chain. I got 400 errors in semma.cc. So because yeah, it was just kind of annoying. I might want to try that again because if we get that to work, it would make things a lot easier. I think.
Twice.
Len's over here trying to learn how to communicate with only mouse gestures because we won't stop talking.
That's pretty accurate.
We're gonna get banned from stream chat. He's gonna stop doing these.
On the flip side, we're stopping him from talking. He's getting a lot of work done.
This is true.
Yeah, I mean, I literally have gotten no work done. I still don't know why this is broken.
Have you tried deserializing it?
Well, I can't deserialize it if the object file doesn't have it.
That is a good point, actually. Yes, very good.
The cough format just has decided to not store the name.
It doesn't store the section name. Is this the same problem with the section string table? Have you implemented the years?
It works differently. I've been looking into that. So basically, if the name is more than 8 characters, the zeros field, the first 4 bytes of name, will be 0, and the offset field is an offset into the string table. Mm-hmm. So I looked and saw, well, are we handling that? Because we might not be. So I went to the sections and where we're looping over them and writing the headers, and you can see that if the section name length is too big, it'll set the offset to the string table size and then write the section name to the string table, null terminated.
Interesting. Okay.
Section header is 0 initialized, so the zeros field should already be zeros.
Yeah.
And that's it. That's how the name gets set, and it doesn't work.
I don't know a whole lot about COF files, so I don't think I can help with that. But is it working for ELF files?
Yeah.
Can you just use ELF files for the time being then?
What do you mean for the time forever?
No, for now, until deserialization is done, until we know it's working, and once modules are working, we can port them to COF files.
Yeah, I don't. They're working on generic object files right now. So the problem lies within somewhere between translating generic object files into COF files.
Okay. Is it working for ELF files though?
Yeah.
Then we can just use ELF files for now and worry about this later.
It just won't work on Windows.
Yeah, well, can't you just... I thought you said GCC can use ELF files in Windows.
It probably can.
Can it? If it can, then we can just use that. If it can't, then yeah, then we need to do COF files or use Linux.
I don't know. I'd have to try.
What I'm saying is, ideally, we should focus on doing all of the module stuff first instead of having to solve 37 unrelated problems, because
Why?
While your head's in module space.
Because by the time we're done with those problems, we'll already have forgotten what we're doing.
Well, it says access is denied. I can't run the...
Okay, interesting.
I can... The GCC does compile the ELF file into a PE32 executable. It just doesn't run.
Is that the... Okay, I don't think you need to chmod it, because is that a thing on Windows? I forgot.
No.
Yeah, I don't think it was. Well, that's annoying.
Yeah.
Lens's stream. Lens gets to choose. What are we doing, Lens? We fixing COF?
I don't know. I don't know what to do. Because even if we start writing a deserialization thing, it's like I can't test if we can... What can I test, right? If I can't get it from a COF object file.
You could test it on an ELF file if you can load those.
Right, we have the ability to load, I think, both ELF and COF. I think we wrote those. Did we not?
I don't know, you wrote those.
You were here.
Was I?
Yeah.
I don't remember. I'm bad at remembering stuff.
I'm pretty sure we wrote something like that. Maybe it's in main.c still.
Main.c. Ah, that. I remember
Yeah.
that now. Yeah. We were loading an ELF section. Yeah. We made sure that we could load an ELF section. So yeah, we can load an ELF section.
Yes,
We
but
can't
not
even use
COF.
COF, we can't even load a COF section yet.
Not yet. We still have
So
to.
Yeah, so we'll...
I'm the only asshole writing code.
To be fair, like the semester's nearly over, so I'll have more time now. I can help with some stuff then.
That'll be good.
What I was saying is, currently we apparently made the decision that we'd be using ELF for now. So let's just use ELF for now until we can get all of the serialization and deserialization working. And after that, we can worry about the COF stuff. I think that's the conclusion we came to, considering that we only implemented, or rather you only implemented loading of ELF files. That's at least what I'm gathering from this.
So what do we... So what do we do now? Local's gone.
Local's gone. I'd say work on deserialization and test it with ELF files. It doesn't have to compile, actually. You just have to... Even being able to just print it out or something would be... Like, if you can load it as AST nodes and just call like print tree or whatever, or print AST or whatever we call them on all of them to see if it's working. Even that is fine for now, if you just use elf files. Or you could implement coff file, like you can also just go and implement coff file reading now if you really want to. We're gonna have to do those two things anyway, in some order.
It's true. I just want this to be done. I've been working on it too long. Okay, we can deserialize a module, hopefully. Can we...
Someone's asking if this is the lens.
Days VFX. Holy shit, is this the lens? Yep, that's me. In fact, we're doing a VC stream, so you can just join the VC and be in the stream. Come say hi. And you'll also get announcements every time I go live. Oh, Paul. So deserialized module, we probably don't need a code gen context.
Do we? I'm not sure.
Where would it come from? We're deserializing a module.
A code gen. Why do we even have one for serialization?
I think it's just there. I don't know.
I see. Okay, we shouldn't need it for either.
So we're gonna get some AST module. There's gonna be deserialize the module. Why is this still not happening? What is this stupid stuff? Okay. Finally. Span metadata. Okay, that's going to be a grab section reference to a span object file, or a string object file, and then as span, right?
Sure.
And then section name, which is going to be inc module section name. And then this returns a span. It's going to be module section. Yeah?
Sure.
What does this do though?
Okay, so this
What do we-
creates a module, and it loads. Like if you look at the AST struct,
That's difficult to get to. What about it?
scroll. Yeah, it has. See how it has a nodes and the types vector.
Sure.
You basically fill in those, and also all the
What?
declarations go into exports too. So you basically just deserialize types. As you're deserializing types, you add them to you create types, or so you create a type struct for each type, as you would if you were passing them. And they're stored in here then, obviously as part of the AST. And we need some sort of mapping from the index in the types table to this. It would probably just be a one-to-one mapping, because they're just by index into this thing here. And then when you deserialize all the declarations, those go in nodes and also in exports, and then you can iterate over all the exports of a module. Am I making sense?
You made a lot of sense. I kind of wanted to die hearing all that.
We're basically turning the module description into an AST.
So here's, okay. Question number 2.
Yep.
What?
It's
Why?
like passing, but you're passing binary, not text.
What do we do with? Why do we fill these? What do we do with these ever?
Okay, that's automatic. That's just when nodes and types are stored. If you call AST make function deck or whatever, the node goes in nodes. If you call AST make type point or whatever it's called, the type goes in types.
Okay, but how do we use those? How?
Well, nodes not at all. And for types, we eventually need a mapping from the types in the types table in the serialized module to a type struct. So that might be, I'm not sure if we can use this depending on the order of deserialization. We might have to use another cache for that while we're deserializing.
Wait, what? So we're gonna have to.
We need to
It's a mess.
we need to deserialize all the types, meaning we need to turn them into type pointer, into type structs, right?
Right.
As we deserialize them and create them, they're automatically going to land in there, because that's where types get placed when we make a new type.
Okay.
Then, when we deserialize the declarations, like functions, whatever, those will refer back to the types. So when we create AST nodes for those declarations, the AST nodes have to refer to AST types, and they have to be the same as in the serialized module. So we need a mapping from the types table in the serialized module to AST types, like type structures that contain those types. I'm not sure whether we can just use this here. We probably need an extra type cache for that, or like the same thing that we're using when we're serializing, or we temporarily store a mapping from type to index. That will be a mapping from index in the type table to AST type.
Wonderful. So I'm gonna have to write another map. That's making more sense.
Yes.
So
basically a map.
the final
Thing.
goal is to just have exports filled.
Yes.
Okay. So final goal, have exports filled. Each node has a type pointing somewhere in here. And each
Yes.
node pointer is a type pointing somewhere in here.
Yes. Basically.
How do we do that?
Well, it's like parsing, but you're parsing binary, not text.
So we're gonna have to parse the header clearly.
Yep, that's the start. That's a good start.
But then do we just what? Each declaration will have a type.
Yes.
And then those types may reference other types that we have to like follow.
Yes.
So it's like a chicken and egg problem here, right?
Well, okay, this is something that I'm not sure whether we're doing that right now, is we sort of need to serialize the types in the order in which they're used, and it might just be that we're doing it the wrong way around right now. That is a bit annoying.
Why do you need to serialize them in the order they're used?
Because that way, when you deserialize them, you can deserialize them in the order they're used, and you'll never have to like defer serialization until later. Because right now, if you want to, for instance, deserialize a struct, and the struct has a field, but that field has a type that hasn't been deserialized yet, so what do? How do you store that as a fix-up somewhere? It's kind of, do you try looking ahead and start deserializing all over the place? How do you know how far you need to look ahead? Because the indexes into the type table, but all the entries in the type table are different sizes, so you can't just randomly access one. You have to deserialize all of them, and only then can you access them by index. So I think how we're doing it right now might not exactly work, because what we might have to do instead is, when we want to, for instance, serialize a struct, is first serialize all of its types, then write the tag, and then serialize the struct. Because we're kind of doing it the wrong way around right now, I think. And that means we also not need like the fixer. I think that might actually make things easier, even though it involves rewriting stuff right now. Like this serialization stuff is a bit annoying. Oh, local is back.
Hey.
I don't know if I'll stick around. There's a big storm a brewing.
Oh no.
So I heard, or I saw the lights flicker and was like, "Uh-oh, guys, I might lose my internet here." And then I responded and I was like, "Shit, I already lost it."
We were gone for like a solid minute or two, I think.
Yeah, maybe 10.
When I got DC'd, I walked outside to the balcony and just started staring at the ring because it was pretty. Talking with
Fair
me.
enough.
He's probably going to unplug his PC, and we're tempted to just go watch movies because I don't care if that TV blows up.
Nice.
Fair enough. We were just talking about a slight deserialization problem where we might have to refactor some of the serialization code, specifically serialized type, which was just written.
Yeah, that's fine.
What is
So-
this?
Basically, what might make again to maybe repeat what I just said, just to make sure it's when we, for instance, serialize a type, if we're serializing a struct, it might make more sense to first serialize all of the member types.
Yep.
If need be. And then we actually start the actual struct entry. And since I think we are returning since serialized type returns the index of the thing, I don't think the order matters. Like we can just serialize the member types first and then the struct will return that index. It doesn't have to be immediately the next index. And I think that wasn't the case before, which is why we did it this way. But then we changed it and now we no longer need to do it this way. I think
Okay.
that's more or less how it ended up a bit like this.
Yeah, that makes sense.
Do it that way, it also has another benefit, and we can just deserialize all the types in order because then, because of the way of how we serialized it, no type will ever have forward references. They'll only refer to types before that.
Yep.
Or to itself, and that's not a problem. Like a reference to itself is not a problem. We'll have to account for that case, I suppose. That's also annoying. If we have like a struct A that contains a struct B that contains a struct C that contains a pointer to A, then we get a circular reference. So we have to make sure that while we're encoding A, we don't try to encode A again. And if that happens, that is a bit annoying, actually, if that happens. At that point, we do need a fix-up table. So that is a good point. What do we do if that happens? That is annoying. So, yeah, that is very annoying, actually.
At this point, you're doing all the graph theory stuff.
Yeah. So I think this is the same problem with if as soon as you have circular dependencies, not necessarily circular, but like indirect recursion, more or less, you kind of need either forward references or two passes. Like forward references require either literally inserting forward reference like in C or two passes, typically. I don't think there is a way around that. So what we might have to do is just oh, that is scuffed though, trying to do that. I can think of some way of doing that, but it is scuffed. I don't want to do that.
My first thought doesn't really work in both cases, so it's not a good thought. Kind of is, I guess. Because what I was going to say is we just only ever, right, you're only ever serializing an actual type. So what if, hear me out, with the struct A containing struct B containing struct C with a pointer to struct A, if when we hit struct A, we delay emitting any struct info, we do all of its field types first, like we're planning,
Yeah.
and then when we hit a pointer to, no, maybe we do. Because what I was going to say then, I guess, is anytime, okay, hear me out. When we hit struct A, we just allocate a slot in the table for struct A and don't populate it.
Yeah, that's.
And since in order to get to struct A from pointer to struct A, you would have to hit struct A anyway. Even if you started with struct C, right, you'd go to its member and do a pointer to struct A, you'd hit struct A and allocate the type. So you'd still want to have that table of, or not necessarily a table, but some sort of flag system so you don't do things twice. But just pre-allocate the data before you go anywhere near its fields, and then by the time you've gotten to it, assuming there's no true like circular dependency on like struct A contains struct A, which I assume Sema would get rid of.
Yeah.
Then that might work.
That works for serialization. That doesn't work for deserialization because if we then need to deserialize A will refer to things declared after it.
This is true, but it doesn't have to immediately refer to it, right? If we're doing things in a struct table here, then you could, I guess you would have to have some way to know what the size of the struct table is ahead of time to like pre-allocate all of its nodes as well.
The thing is, they have different for the entries of it don't have the same size in the serialized table.
Right.
You can't really skip ahead.
But if you did know how many there were, you could pre-allocate the data, like the deserialized version of the data, and then populate it as you iterate through. but that would still requiring knowing how
Oh.
many, and you don't because it's a tree.
What you're saying is, if we know that there is like 60 types in the table, we
Yeah.
can allocate a blob of 60 struct types.
And then
Yeah.
populate them as you hit them.
Sure, that I think might work. Yeah. That
Yeah,
is a
you'd
good
still
idea.
have to know how many there are somehow. And since
Yeah.
you're running through a tree and just hitting whatever you hit, you don't know the count beforehand. So you might want to serialize into a byte array and then append that byte array after a count that you've calculated after you serialize the byte array.
Serialization, I think, works the way you said it, where we just and allocate a dummy entry.
Yeah.
Just emit all the fields, have them refer back to the dummy entry. That's not a problem. So I think that just
because regardless, you're going to know what the size of the dummy entry is because you know the size of a struct entry and you know the size of the number of fields you're referencing.
And we know how many types we've emitted because we just count. We just keep track and emit a count and increment the count every time we actually emit the type. So we'll know how many types we've emitted by the end. So then when we deserialize, we can just allocate that many, and that way we effectively have forward references. Because if a type refers to type 57, we can just give it a pointer to type 57, even if type 57 isn't filled in yet.
And then by the end of deserialization, it will be filled in.
Yeah. That works, actually. That's a good idea.
It just requires us to serialize it completely differently.
Yes.
A little bit.
Yeah.
I think so long as you have the count for the number of types at the start somehow.
But then
that's like the biggest change necessary.
I'm still confused because in the serialized version, the forward reference isn't going to reference type 57. It's going to reference offset 732, where type 57 happens to lie.
Anyway, I'll leave that for you guys to figure out. I'm going to turn off my PC and go watch movies, I guess.
All right, chill, have fun.
If I come back, it means we didn't watch movies.
Bye, local, have fun.
So, yeah, we'll have to change how we serialize things, unfortunately, I think.
I hate this.
Because, I think the reason why we did it this way is because we were not returning the offset or something. We were doing something else differently that necessitated this, but now that's not necessary anymore. That's why we can do it this way, I think. I'm not sure what happened there. Maybe it was just bad design on my part. That could also very well just be the case.
It's a possibility.
We have an idea of how this might work now. Because the solution to forward references, you need to create forward references, and allocating 60 empty structs will do the trick, yes. So yeah, I think we'll have to rewrite serialized type before we can even do this.
How so? So even if we're going to forward reference through index, the same way we do like basic blocks, doesn't that still mean that whatever this returns has to be an index?
That has to be an index, but not an offset instead of not a byte offset, but just an index in the table.
Yep, which the nth type that we're serializing is what we return. We return n.
Yeah.
So the first type we return 1, the second type we return 2.
Not necessarily, because the first type we are asked to serialize, if that's a struct.
Well, right.
Yeah. We allocate the struct entry first. That's true. I think we have to put the struct entry first, because if anything else refers to it, it has to already be there. Because of the problem that I just mentioned with the nested pointer thingy. We allocate the struct entry first. So that is now at index 0, if it's the first one we're serializing. And then that's just an empty entry of the size of whatever type struct entry is.
Right.
Depending on how many members, fields it has, whatever. Then we call serialize type on all of its member types. That will then potentially serialize struct types recursively. We'll cache that somewhere in the type cache thingy. And eventually it will be done. And then we'll have the types, the still blank type struct entry, and all of its member types and nested types below that. Those have already been serialized, all of them. And then we can fill in the type struct entry and return off, in this case, index 0 for the struct entry. We will have serialized more than one thing, but it will be in place 0. Not that any of the code is.
Isn't that what we're doing?
Is that what we're doing?
For each member.
Is that what we're doing? Hold on.
Yeah, we write
that might be what we're doing actually. Hold on.
Because we just
So we
add to the
circle that.
size here,
Yeah, that is what we're doing, I think.
and
So
then we go
circle that.
back.
Okay, I know now what's happening. So yeah, okay. I'm a bit slow today, my bad.
It's
Because
okay.
the thing is, I suggested doing it differently, putting the types first and then the struct after, but that doesn't work if we have struct A contains B contains C contains a pointer to A.
Right.
That doesn't work in that case, so we have to do it this way first, but we're actually already doing it this way. So I suggested changing it to something else, but then local suggested doing it differently, so I suggested changing it to something else again that I didn't realize was the thing we're already doing. So to summarize, I think
Bike
we're
shed.
already doing what we need to do in the serialization. So now we can just deserialize.
Well, that'd be ideal. So what do we do then?
So one more thing, we need to know how many entries we have in the type table. Two things. The index, is that an index or a byte offset currently?
It's a byte offset.
It needs to be an index.
Why?
Because of how we're going to deserialize it.
See, this is confusing to me.
Okay.
What's the difference between between the index and the byte offset? Because the index is going to be literally known. Like, why would we store a known index? Like, we iterate 3 types and then we go, this is the 3rd type. Like, we don't need to store that. We can determine
no, we're
that.
not storing that. The function returns that. I'm talking about the return value from. Because
And this is
serialized
what's
type returns an index, doesn't it?
yes, and that's what's stored in the type table to refer for struct members or things like that.
Yeah, but okay. The thing is, the main reason for that is if we just deserialize them in order. And in order to do that, we need to, if we want to deserialize them in order, then we kind of need the indices. So, okay, hold on. I'm bad at explaining. So the way we're going to deserialize this is what local suggested is, and I think that's a good idea, is if we know we need to deserialize 60 types, okay? You have 60 things in the types table. What we do is in the deserializer, we allocate 60 empty types up front. And then we deserialize into those empty types as we go, right? The first type in the table goes in the first empty type, and so on. And what that enables us to do is, if, for instance, the first type is a struct that contains a reference to something after it, we can already fill in that pointer in the type struct. We can set it, okay, this points to type number 37, even if we haven't deserialized type number 37 yet. And when we deserialize type 37, we'll fill in that struct, but the pointer in the first struct that points to that type will already be filled in. Like, we'll just set the pointers as we encounter them and just fill in the structs as we go. Does it make sense? I should have like draw it.
No, I get you now. That's so it has to do with
It has
So-
to do with this stupid case of like these circular references.
Mhm.
Those are the stupid ones.
Otherwise it's not, we wouldn't have to do that
It's so much
because
easier
we could just
to
follow.
that,
Yeah.
yeah.
Also
The cycles, yeah.
first time chat from Dramen. Hello, thanks for the wave. King Bun says Giga Chad local. That's right.
Yeah, that was a good idea, just allocating them as a blob. I have no idea why I didn't think of that. That's a pretty good idea.
It
That is
is.
basically forward. I'm pretty sure I've done something like that somewhere before. I can't think of where, but that is something you just do when you deserialize. That makes perfect sense. Yeah. You just fill it in. I'm pretty sure that's what I'm doing for something. I think like functions or something. Yeah, that's basically how functions work in my compiler. You just create all the functions up front in LLVM, and I think this compiler does it too. And then you just fill in the functions later. So yeah.
The person who I read his name, he says, lol can call me DWRR, haha. Like, is that supposed to be easier?
I'm not sure that helps.
I'll just call him Dwyer.
The W is supposed to be a U. Are you Welsh by any chance? Because in Welsh, the W is pronounced like a U.
Duh. It would be duh then, right?
Dur, but yes.
Yes,
Dur
that.
in Welsh. Because the trilled are.
Directory write read read. Ah, yes. That doesn't help either. What is, some people pronounce it Dewar? I don't even know how to say that.
Dwa. There's
Dwar?
multiple ways of pronouncing that. Can you fill in the IPA? Can you give us the IPA for that, perhaps?
That's right.
That would help because English spelling is horribly unsuited to represent any sort of pronunciation of anything, really. So back to this. First thing we need to do in serialized. So in serialized type, we need to refer to types by indices, not by offsets.
Yes. That is true.
Because the byte offset is going to be horribly useless to us when we deserialize. That's the problem.
Well, it's confusing. We basically, at this rate, are just storing, the index implicitly. So here's the thing. We don't have to return anything. A serialized type doesn't care now, right?
We have to return the index.
How do we do that? We just have to pass in the index then.
Instead of, okay, we have to have, do we have a context or something?
No.
We don't. Add a context, put an index in there.
That's
There we go.
horrible.
Serialization context.
I hate
No, it
this.
makes sense.
It doesn't.
The context states are preserved across calls to the same serialization function.
Stupid.
That makes perfect sense, I'd say. Just make a serialization context, throw it in there, and throw the and the type cache, throw all of that in there. We're basically passing in a context already. We have two parameters that get preserved across calls. That's a context, just not in two parameters instead of one.
So complex.
It's called packaging your data. Or bundling, whatever you want to call it. Yes, there we go.
So useless.
Serialization context. Now we're doing proper serialization. So throw everything in there. Yeah, there we go. Good. And if we need anything else, we can just add it to that. It doesn't even need to be a pointer. We can just put it in there, actually. Right?
What?
We can just put the string buffer in the context, I think. It doesn't need to be a pointer. We can just put it in there. Right?
Well, here's the problem. This isn't going to work because we're going to need like 4 serialization contexts. Well, we're writing to out, but we're also writing to declarations, and we're also writing to types, and we're also writing...
Oh, I see what the problem is. You're doing it... Why are you doing that?
What do you mean? Unless... write bytes...
Hold on. You're doing it this way. I see what you mean now. I see, because we have... Yeah. Okay, sure. Sure. I was a bit... Yeah. Okay, that makes sense. So I would... Do not put that in the context, then, I suppose. Just the type cache and the index.
Okay.
Sure. Well, actually, you might not even need the index, because the size of the type cache can be the index, isn't it?
That's not how many types we've encoded.
Isn't it? Because we add it when we encode it, and if we've already added it, we don't encode it again. We just return the cache one. So therefore, the type cache, I think, is what we've serialized.
Okay, screw the serialization context then. But that means this is weird. So this means all we're going to return every time is the size of the...
No. Almost, except for at the beginning we need to save, because we put that right here. So that the cache size, sure. And if the type equals, we need a for each index in there now, instead of a for each on line 48.
What?
We need the index now, right? Because the index of a cache type of a type in the types table is also its index in the type cache, because it's currently just the vector of the hash map.
We could just keep...
Fun, isn't it?
We could just have this be the same, right?
This works. Wait, hold on. The byte... It shouldn't be called byte offset anymore. That's one thing. Yeah, it should just be called index, I think.
Right.
Byte. Use some of the confusion. You can just query replace byte offset by index, maybe. Yeah, see, query replace is what I'd suggest.
Yeah. I was just making sure there's not anything crazy.
So query replace asks you every time, so
True, but I don't want to spend
Index.
time figuring out what to replace it with or coming up with a name.
index. I do index.
No, I did one that I didn't want to.
Oh, okay, see, that's why.
I pressed space too many times.
Yeah, don't.
Yeah, those are correct.
Can't you undo, maybe?
It'll undo every one, I'm pretty sure.
No, it will undo them one at a time.
That's weird. I've never done that.
Okay, I don't. You also haven't used query replace much, I think so.
It's true. Well, it didn't explode.
It didn't explode, but we still need to do one more. Yeah, hold on. Oh no, this is fine actually. This
It
is
should be
interesting.
done now, right?
This is it. Okay, hold on. This is very funny, actually. This is very interesting.
What?
We don't even need to. This is brilliant. I'm loving this. We don't even need to store the index in the cache type because it's the position of the cache type in the cache is its index currently. Because this is just a vector, not a hash map. If it were a hash map, we'd have to store the index. Well, then, yeah. But currently, the position of a type in the cache type table is its index. So we technically can just make this a vector of type.
Yes.
Yeah. And just do for each index. This is fascinating. You know,
I don't think it
typically,
simplifies
when-
anything, but yeah.
it is fascinating because typically when this sort of stuff happens where data structures start just clicking into place, typically that means you're doing the right thing. Vector of type pointer, I'd say. Otherwise, we're gonna end up in pain. Yeah. Typical to me, this is a sign that things are working for each index, and then we just need the thingy. Yes. Would you look at that? I would argue this is simpler.
Possibly.
And we don't even need that anymore. We can just push the type and return it. And that's technically no longer type record begin. That should probably be called index now. Because type record begin, I think we still need that for something else to actually write the record. So
What do you
that
mean to
should
actually
be-
write it? What are you
Okay,
talking about?
Because we're like, I'm not sure how we're doing it below. Maybe we're just storing the current position whenever we need to like jump forward. So in that case, we don't.
What do you
is
mean?
Type record begin used for?
It's the
type record
return
begin?
value.
It's just the return value, then you can rename it. If it's just the return value.
Yeah.
We don't
What
need-
else?
Yeah, in that case, just rename that to index or whatever. Sure. I thought it was being used to like temporarily store where we are to, but apparently we're doing it differently. So yeah, we're probably just saving the positional. Yeah. Sure.
It's in
I
like
think
here.
that might work. Yeah, something like that. Okay, we're doing it that way. Yeah, okay, that works. There was an underline. I think the LSP was complaining about vector push.
It's fine. It's suspicious usage of size of a
It's
pointer,
okay.
pointer to
Because
aggregate.
the thing about vector pushes, when you rename stuff like that, it could be that you end up pushing the wrong thing on the vector. So that's why I was a bit sus. But it's just that. Okay, so this is very interesting, actually. I think that might be it.
Supposedly.
Supposedly.
I mean, there's still just a dollar and an ampersand.
Yeah. Okay, now deserialization. One more thing. We still need we might still need the serialization constants because we need to. Oh no, we don't because we have the type cache. Hold on. In the header, in the module description header, we need to store how many types we have.
Why? For the whole
Because we need to
thing.
know how many I'll pre-allocate. Yeah.
I mean, we could just
So,
say if it's a vector, couldn't we just like reserve?
yeah. We can. No, what I'm talking about is when we deserialize, we need to know how many to pre-allocate. So we need to know how many types there are. But how many types
We
there are
do?
is the size of the type cache. So what we need to do is when we're done serializing, We need to store the size of the type cache in the module description header.
So
When
why
we're done
can't
serializing the thing.
why can't we just have a vector that we keep pushing to?
What do you mean? Well,
So everything's by index, right?
Mhm.
So why can't we just have a vector that starts out as like size 8, but if we reach something that's index 37, then we reserve 37 to make sure that the vector can hold 37 types?
I mean, you can do that too, but it's not worth it. We'll have to reallocate all the time because we're going to have to get 37 anyway. So it's more work to do that instead of just allocate them upfront.
Okie doke.
That's just more work. And we need to fill that in when we're done with everything. There we go. Yeah, very good. Types.
I don't think that's right.
No, I think it's right. The type cache size, whatever it was called.
Yeah, I think it's something else. I'm suspicion.
What is the type cache called? It is called cache. It is called cache apparently. Okay. Very good.
First time chat from Star Legend God. Hey, so is it fine to multitask different projects or should stick one until it's done? Do whatever you want. You work whatever's the most efficient way for you.
I will say the way they're asking that, I'd say, yeah, sure. If you're sick of just dealing with serialization in the compiler, go and work on the text editor or something. Sure. It's better to switch to a different thing and work on that for a while. If you're just so sick of a project that you're not making progress anyway, sometimes you just need to take a break from something. So yeah, I'd say go for that definitely. So long as you don't start 500 site projects all at once. Like if it's too many all at once, you're not going to get much done on any of them. I will say that. But if it's just a few, sure, go ahead. There's no reason not to. Is what I'd say. Okay. So now I think we're done with serialization.
Oh, dear God, I hope so.
Well,
So yeah.
We'll revisit this one if we ever add templates. This is going to be fun.
Yeah, you are going to add templates if we ever do.
Yeah, sure.
No, I'm just kidding. I just don't know how that even works. It's
Well,
basically
we've
just
already
going
done it. We're doing the same thing just for all the other AST nodes. Everything that we use types for all the other AST nodes, more or less.
So we'd have to serialize actual AST nodes themselves.
Yes, we have to serialize the entire goddamn function declaration with every single expression in it. Yes.
That's my least favorite.
Yeah.
You know what we might do?
What?
We might allow
Let's say the
templates, but not allow exported templates.
Feels like a bit like if you want to have a standard library vector, how is that going to work then?
Generics.
That's kind of like templates basically already.
Yes.
Or what do you mean something else by generics?
Well, sort of, yes. Generics, templates are set by the caller, whereas generics are set by the callee.
Well, the only problem is we need to instantiate a vector of. Okay, for a vector, the thing is, vectors mostly work the same, so that's a bit. You just need to insert some. But the thing is, it's a more complicated data structure where the size of the thing depends on what it's templated on. How do you do that then?
What do you mean? So, like a generic, let's say it works like this, and then you say it's one of. This isn't the right syntax, right? You could say it's one of integer or byte.
Okay, so you only allow, yeah, that is constrained generics. That is definitely.
That's what I'm talking about.
Sure. The thing is, how are you ever going to constrain a vector of all 37,000 data types that people might want to pack into vectors?
Well, we'd have like concepts or interfaces, something like that. So
okay,
we're going to have like a type that must.
So you do the go thing. Yeah, sure, that works.
Well, I don't know if that's how it's going to work. but
That is
that's how it's working in my head so far.
Yeah.
Because I don't want to have like code bloat where it's like, oh, we had to instantiate 800 different types of template for every single.
That's an interesting one, because that's definitely a template too many template instantiation is definitely a thing. This is why standard format is so complicated. It's because it uses type erasure to avoid instantiating too many templates compile time, because people have found that it just creates so many templates that compile time suffer with type erasure you can bring it down from 15 seconds to 2 seconds the compile times.
Exactly.
The only reason we have type erasure in there is because the compile times get too bad. That is a problem sometimes if you get too many complicated nested templates. Most of the time, it's typically not that big of an issue in terms of like compile time. Sure, always going to be longer if you want templates, but the thing is, at runtime, like most of these things will get inline most of the templates, and if they're unused, they're just going to get discarded away. And most of them are just types and information present at compile time. So it creates some level of code bloat, sure, but it's not that bad typically. Otherwise, people wouldn't be using them. So I think the trade-off that you have, sure, you'll end up generating more code, but the code will be faster because it can also be inlined and optimized on a per type basis, which is more or less the point of templates.
Yeah, I see what you're saying. The benefits could outweigh the cost.
And the thing is, this is something that I generally have a pretty clear opinion on, is if the choice between making the life of a compiler implementer or a compiler developer more complicated and making the lives of the users more complicated, I'd always choose the former, even though I am the former and I have to suffer for that. Because it's better if the compiler devs have it harder than if the users have it harder. And runtimes being slower is also a way in which the users can have it harder. I also got I still don't know how to pronounce that name, from DWRR.
Door
Is
handle.
that how you say it?
Yes.
Door handle. Sure. On a scale of brainfuck to C to C++, where would you say the goal complexity of intercept is?
Complexity? We're aiming for like... Okay. I don't want to say the wrong thing here, but when I hear that, my thought is Python. Where somebody looks at it, they look at it and they go, I mean, it doesn't look like I understand it or like I know what's going on right away, but I don't look at it and go, oh God, the horror, like Rust.
Or complicated C++ templates.
Right. Yeah, you get it.
Sure. Which is an interesting answer, because C isn't that either. Try looking at some random C code and so
Oh, it's horrible.
Whatever it is.
Exactly, yeah.
It's like, yeah.
Obfuscated.
C isn't there either. So I think like C and C++ are both rather complicated, just in very different ways. C++ is just a syntactic mess sometimes, and C is just a mess. Full stop.
Yeah.
I suppose. So, we are doing... Well, we need to deserialize all the types first before we can even attempt declarations.
What do you mean?
Declarations refer to the types. We kind of have to do all the types first.
Why?
Allocate them.
If we're... Hold on. If we're pre-allocating an entire fucking thing of types just to be able to have forward references to pointers by index, then we should already have the pointers when we're deserializing declarations.
Yeah, well, you haven't pre-allocated them yet.
Well, no, I haven't. This is the first thing I'm writing in this function.
What I'm saying is, yeah, we need to pre-allocate before we can... Oh, I see. Okay, hold on. Never mind. I know what the confusion is from. You wrote to do pass module declarations, and I read it as the comment describing that we are passing module declarations, whereas you're passing something else right now.
I see. Yeah, this is all one comment.
Yeah. Okay. Sure. Now it's making sense. Yeah.
All right.
Okay. I thought you were currently trying to pass module declarations without having the types allocated. That's why I got confused.
I see where you're at. Yeah. So we'll pre-allocate the types.
Mm-hmm.
And then we'll go through and like populate type info from table.
Sure.
Okay. So what do we push
But
to
that
the...
what doesn't matter. The only thing you have to do is pre-allocate the types first. After that, doesn't matter what you do in what order. Because I don't think declarations refer to each other, so that's not an issue. Otherwise, we'd have to also pre-allocate all the declarations, but I don't think that's an issue here.
I see what you're saying, yeah. Yeah, that shouldn't necessarily be...
Because declarations in code may reference each other, like initializers, but we're not storing the initializers because those have already been emitted into the module they belong to. We're only storing the information, so there shouldn't be any circular references here that aren't types. And the types we pre-allocate. That shouldn't be a problem. It's all coming together now. This is starting to make a lot of sense with pre-allocating all the types. At least for me.
I get what I did wrong.
Because it's now less of just throw bytes at it until it works, and more of we actually have a plan on how to deserialize and serialize it.
It's true. I hope. I hope. Why are you mad? Stop being mad. Okay. Yeah? So we get the name length.
Sure.
We get the name by pushing the name putter. Right. So we get the end of the header pointer.
Good God, the casts. Yeah, I think that looks right.
So the end of the header pointer plus the size of the name length.
Length, and that should be the name, yes.
And then
we can just copy it out.
right. But to push it to a vector.
Please don't push individual characters.
How would we do this then?
There's a function called vector reserve that allocates n things in the vector. Please use that.
So you're saying just reserve the mem copy instead?
Reserve and mem copy. Yes, that is why we have mem copy.
Yeah.
Mem copy will do exactly this, just better.
Will it though?
Yes. Well, to be fair, if the name of the module is 3 goddamn characters, I don't think anyone cares. But as a matter of principle, I don't think doing it manually is generally a good idea.
Okay. We feel good about that?
Yeah, that looks better.
Okay. Then
It's interesting because we don't have a whole lot of string. All of our string manipulation functions are mostly just vector manipulation functions. We should really write a dedicated string header or something at some point.
possibly.
Yeah, with possibly SSO, but doing that in C sounds like a pain.
Yeah, it does.
I'm sure I want to do that.
Okay. So then
again, C allows type punning with unions, which is UB in C++, so we at least would not run into that. We could just use unions and be done with it. Whereas in C++, while the way we're doing it in NZOS, I'm pretty sure if we compile it with Clang, it might complain, because I think it's technically UB, but GCC allows it. Just so you know.
I see.
Using union and doing strange things with it.
Within pre-allocated types using...
Because type punning with unions is UB in C++. It's only allowed in C. In C, it's expressly allowed by the standard. That's a nice thing. That's like the one thing that C does better than C++. It allows type punning with unions.
Which is reasonable. I don't see why it wouldn't happen. Like, why would C++...
C++ is much stricter about lifetimes and all of that. And what is type punning again? It's okay, fundamentally, type punning is kind of removing type information or accessing a type as another type. For instance, if you have a struct S and you're just reading individual bytes from it, something like that would be sort of type punning. And with unions, you can do that very easily because you can make a union of a double and a long. You store the double to it and read it out as a long. And that way you get the byte representation of the double as a long.
Log 10 go burr. Get pointer with... Okay. So then this should be, what is the type? What do we store as the type index? What size thing is that?
I'm not sure.
We'll call it a uint64t.
We can check in the header. Shouldn't it be somewhere? Oh, the type. Wait, what do you mean the type index exactly?
The thing that we store for each declaration, the type
For
of it.
each- Oh, the type of a declaration. What that is stored as is what you're asking.
Yes.
What was it? I'm not sure. What are we returning from this serialized type? I think apparently it's a uint64t. It would seem that it's a uint64t.
It's probably a use size mistakenly, but yes.
Okay, that is on most systems. That is the same thing. Yes. If we're ever compiling this to WASM, we'll be very sad because on there a size t is 32 bytes. No,
That's
32 bits,
huge.
God. I always keep doing that because the reason for that is that WASM 32 has 32-bit pointers, so size t has to be 32-bit. Otherwise, very bad things will happen.
Yeah.
The size t typically is the same size of a pointer. Otherwise, it's a bit useless. And saying that uint pointer t exists, so yeah, I'm not sure why that needs to be separate type. But then again, C is old, so there are systems, or at least there were systems at some point where a function pointer had a different size than a regular object pointer. So anyway. What exactly is happening here? What am I looking at?
Basically,
Okay. Yeah.
we're going to have a vector of type pointers, types. We're going to vector reserve type count, right?
Yeah, and we also need to create all of them because the types vector holds type pointers.
So what does that mean for me? I have to do for each?
Yeah, you have to. I think there is AST. Oh, but we can't create a blank type. I think. So I think you just have to malloc or calloc, whatever. Doesn't matter.
What,
Calloc it.
so does this mean, what does this mean for me?
Okay, what you can do here is you can. So the thing is, we have a vector of types, but the types are pointers. So what you could do is just calloc a blob of 60 types and then just set each type pointer to an index into that blob.
Create the vector by hand.
Yeah, create the vector. Yeah. So no, with the vector, we need to then store 60 pointers into the. No, that's not what I meant.
It's not?
No, because the thing is, okay, it's an indirection problem. The vector holds type pointers. Okay.
Right, and we need type count type pointers.
Yeah, but we need to also allocate each of the type a type struct for each type pointer.
But we don't have what type we need to make yet.
They're all the same size.
Okay.
They're all the same size.
Okay.
That's otherwise this wouldn't work. That is true. With the one unions, this would all fail horribly. But they are unions. So
I see what you're saying now. I see what you're saying
How
now.
many pointers? We allocate a blob of 60 types, and then we just initialize those 60 pointers with the blob. Yeah, there we go. That's nice.
I see what you're saying now.
That is not a type pointer, it's a type pointer, but yes. The type of type blob is type pointer, not type pointer.
Yes, you're right. You're right. And then for each of the pointers, we have to say it is equal to type blob plus plus.
No, you have to do. Please do it with an index. I'm not sure how this works exactly with setting pointers like that. That there's some because of how C works. It's like I'm not sure how macros can do that too well. No, that doesn't work. You need to set types data I to yes. There we go. Type blob plus I. Or plus plus, whatever. We don't need it after that. Sure. There we go. That should work. And you can actually just you don't even need to make a separate variable for types. You can just set ast.types to that. You can just use that, or ast arrow types, because that's what that's going to be. This vector of type pointer
This one.
is AST. Yeah. So module arrow types is that thing.
I almost typed arrow.
It's underscore types underscore because you're not supposed to actually use that typically. But we're doing curse deserialization black magic here, so it's fine. Because the way this is used, that if you create a new type, the AST will store it in here so we can free it later. That's the only purpose of this originally. But now we can kind of do this and initialize it in a way that wasn't intended. And because C doesn't have private, I put underscores before and after. That's like a sign of do not use this thing unless you absolutely know what you're doing. But we do know what we're doing in this case, so we can do it. That's the same thing with how I think I DM'd you that with how I added a check to my compiler to make sure I didn't misuse a function later. That's the same thing basically. Like if you ever want to access that, the underscores are assigned. Do not ever access that unless you know what you're doing. In this case, we do. So
Do I have to calc the node pointer? I'm confused.
what?
Do I not need one yet?
No, we create those when we actually pass the declarations. Those we'll create one at a time.
Well, that's what we're doing here.
Yeah.
So we just make a declaration?
Sure. Depending on what it is. If it's a function, I think we need to make a function instead. Because a declaration, I think, is a variable declaration.
So we'd have to make that?
Make a function if it's a function, make a declaration if it's a declaration, and so on.
How do we know what's what?
Well, that's in the declaration. I hope it's in the entry, isn't it?
I think I just assumed everything was a fucking declaration. Because we
Okay,
only
in that
export declarations.
In that case, we'll know from the type. If it's a function type, it has to be a function.
But we don't have the type info yet.
Well, that's because we need to deserialize the types first.
That. I'm gonna explode. I literally might, I might tonight just not wake up after I go to sleep.
Spontaneously combust, eh?
It's a possibility at this point. I guess I'm an idiot and I have to, no, we have to, so we have to,
I will say this is rather cursed. Like all of this is not that easy to reason about if you don't have an idea of what you're doing. I sort of have now. I'm not sure I fully have an idea, but I think I do more or less. So yeah.
okay. Based on type kind. What do we do? What?
Yes.
What am I even doing here? Where do these nodes go? What is this?
These nodes go in the module. The module takes care of that.
In the module exports? Or
Yeah,
the,
well, to that as well. We need to add them to that as well. Yes. Yes, correct.
okay. Okay.
Deserialize the types first.
Yes. So add node to module exports. I'm just, in case anything happens, I gotta save all this crap.
I'll remember it, don't worry.
Thank you.
Because now that I know how it works, I'll remember it.
10 years later, I'm gonna be begging you.
Well, yeah, 10 years later. I don't know about in 10 years, but tomorrow or next week, sure, I'll remember it till then.
Thank you.
And after that, it's going to be in the code base, so I'll remember it after that. It's just going to be in code, which is much better than the line in the code.
That's right. Then you use the Git history.
Yes, that's what Git is for. That and fixing the just currently monitoring my window if it's really sealed.
So we have to deserialize types in order for the indexes to make sense.
Yes.
But there's not really doing it unordered would be insane. So that's fine.
Doing it unordered would defeat the whole point of allocating them beforehand and using indexes, yes.
So to deserialize the type info,
You iterate from 1 to whatever the number of types is. You keep track of the offset as you go, and you call deserialized type, which we haven't implemented yet for each entry. And each call to deserialized type will deserialize that entry and only that entry. Forward references will be resolved automatically later on, and we'll only fill in the currently still empty pointers, which we've already allocated. Does that make sense? Am I being confusing again?
I think you're making sense. It's just, it is slightly confusing. So we need to access the types at I and have that be the serialized type.
Deserialize, yes.
Thank you, deserialized type.
No, close. We call deserialized type and pass in module types.dataI because we need to fill that in. We pass that in. It doesn't return anything because it doesn't need to. It just fills in a struct. That's all it does.
Out parameter, gotcha.
Yeah, well, sort of, yeah, it's not even much of an out parameter. We just fill in a struct that we've already populated. I guess it counts as an out parameter, sort of, so writing to it.
So that means,
Yeah.
but what's the input?
What is the input? The input is the current byte offset in the types table. So we'll keep track of where we are. We start at the start of the types table. So I guess deserialized type can return how many bytes it consumed or something. If you want it to return something. Yeah, just make you could use a span, you could use a pointer, you can do whatever. A pointer would also just work.
Why is... Okay, so what do you mean a pointer would just work, by the way?
So we just need to deserialize the type. We just need to read data from the input and advance the pointer, basically. I think that's all we need. And if the type table is malformed, then we'll just crash because that's the user's fault.
Yeah, that's... Well, it's our fault for serializing the incorrect module metadata, but yes.
It's not be our fault, but also if the user just renames something to .o and puts nonsense in the section and throws that at us, then we'll crash because that's their fault.
Okay, so we get the start of the type table.
Yeah, I think that's right. And then in the loop, we do type table plus equals deserialized type, and we also pass type table to deserialized type. Something like that, perhaps.
Wait, so deserialized type returns the amount of bytes that it deserialized?
Yeah, either that, or we just make it. We'll have to update it anyway at some point.
Yeah.
Or instead of plus equals, we could also just make it equals. We could just return the new one instead of having to keep track of how many bits. Just type table equals might be easier.
So we're gonna have to have. Yeah, I see what you're saying.
And just return the new one. There we go. That makes sense, I guess. Yeah, that makes sense, I think.
So this is just a pointer where we currently are parsing from, where to deserialize from.
Yeah.
We return the pointer. Okay, so this is like a lexing thing.
Yes, it's sort of in between lexing and parsing. It's like parsing without lexing, basically.
Exactly, yeah. Hey,
I said it was like parsing, just go passing by.
You're right. I didn't see it. I didn't see it, but now I see it. Doorman, that's right. Cursed deserialization black magic. I think that's the technical term, right?
Deserialization black magic is a good term, yes.
So what does this return? It's supposed to return the
pointer.
Oh, you're right. This is still
Can you hear my floor creak, by the way?
No.
Good. good. That's good. You also can't hear my AC, which is like really loud to the point where I have to wear headphones, so that's good. I guess microphones, this is a good microphone that just picks up my voice, I suppose.
Yeah, my microphone picks up everything.
Mine is just a Blue Yeti, so.
Nice. I have a Blue Yeti sitting at the side now. I think I'm going to sell it.
I see.
But I might keep it just in case my like fancy audio stuff breaks and I can't
That's
afford it.
an idea. That's an idea. Agma recommended this to me, so I had a real stuff from before that.
I see. Like an Xbox headset style.
No, just a very cheap, like $10, $20 microphone from some, I don't know,
I see.
some random thing I picked up in some hardware store.
I see. So the from pointer after advanced past deserialized type. And then what else do we pass to it? The type that we want to fill in, right?
Yeah, the type I want to fill in.
Okay. And that should deserialize the type info, right?
Yes, that should do the trick.
Okay. Question.
Yes.
Some of these types will deserialize other types.
Nope.
What?
If, for instance, a deserialized type has to deserialize a struct, okay, and the struct contains types that haven't been deserialized yet, we know their indices, right? So we can just fill those in, and those will point to the. I suppose what we do need to fill in to pass to this is the pointer to this first type, like to
Yeah.
the thing. Yes, that is a good point. There we go. Now we have everything. That is a good point.
It felt wrong. I was like, I'm confused. So we just need to pass in.
What I thought not type table, no, but yes. No, that dot data I think might work. Type stop data because it's it's module underscore types dot, yeah, that thing.
And this is just to the pointers, the vector of pointers.
Yeah, we can index into that. Like the index. Okay,
So it's
to fill in a type, we just index into that. Yeah, okay, sure. Yeah, that makes sense. Yeah.
Oh yeah. So then when we get the
He's getting it. He's understanding.
It's clicking.
Making sense. I'm making sense. Isn't this wonderful?
Miranda says hello. Hello, Miranda. In case you aren't aware, today we're doing a VC stream where I'm in the voice channel in the Discord. It's publicly open, so just feel free to join the Discord, get announcements every time I go live, have awesome discussions with awesome people, and be part of the stream. And it's good to see you, Miranda. Thanks for tuning in. Nuclear Cookie, EXO, Nurkund, Moned Clue, Fortran 999, Soda Limon, and the Rarity Pants too. Thank you so much for the follow. Oh, and Daughter House, in case and Half to Mayo. Oh my lord. Thank you, everybody.
I still need to implement proper deserialization in my compiler, so it'll be interesting to compare how much easier or at least different this will be to implement in C++ as opposed to C.
I think it'll be really similar, honestly, due to the limitations of having a file format.
Mm-hmm. I mean, it should be easy to just write stuff to a buffer, though. Because I can standardize and I don't have to get the size manually.
You are right.
It should be easier.
It won't quite be like the F-write syntax.
Yeah, it won't be like write bytes. That's true.
Technoprax, thank you so much for the follow. So we have a serialized type array, and then we're going to say type kind. How do we do this?
Sorry, I was trying to swat a bug.
That's okay. Well, all of our make type stuff
Yes.
returns a type pointer, but we have
That
to.
is annoying. We have to fill it manually. Oh,
So we have
gotcha, you bastard! Die, perish. Sorry. I finally got the damn thing.
That's
Yes,
awesome. Yes.
I got it. It is
Stupid bug.
dead. Damn thing. Out of here.
Cursed vile beast.
So, anyway, the flying abomination has been unmade. Now, let's get back
Da
to
Vinci
this.
would be sad.
That does not work because it allocates a new one.
Well,
So
yes.
you'll delete memory.
That's not
You'll
even
reallocate memory twice.
that's not even the issue. We don't have an AST to pass it.
Yes, that is also a problem. So we'll just fill it in manually. It's not a problem. We'll just fill in.
It is a problem. Excuse me.
It's annoying. It's no problem.
Ah. Tomato, tomato. Okay, and then of, see, this is where the type pointer thing happens.
Hmm.
We use the element type index. Yeah. Just technically right now an offset.
There we go. Yes.
We say types plus that.
No. Types index that, but yes, because types is type
Yes,
point
yes, yes.
correctly.
That's right.
There we go. You could pass in the type blob and then add that, but it's the same thing, really.
Yeah, yeah.
And this is more robust in case we change the other thing.
And then this element type offset is kind of now named confusingly.
It is named confusingly, yes.
Index.
When you refactor, things just stop being named properly.
Index. Okay, there we go.
There we go.
Arrays.
I think that's all there is to arrays.
Okay, so as far as this
It's also
goes,
funny, I literally just called it of array of.
it works really well.
Mhm.
I like that style of name. Because of isn't a noun,
Yeah.
which is confusing. We've named something using a preposition.
Mhm. Point
Oh.
two,
I also really like that, actually.
Is it
Very
Doorman?
It is, actually. Hello.
it is.
Hey, welcome.
So how are you supposed to pronounce your name? I'm curious now.
Oh, yeah. I guess I could actually say it. I sent the
Yeah.
IPA in chat. It's Door.
Door.
But door handle works too. I mean,
Okay.
your choice.
Okay.
Okay.
And this is literally just going to be this thing. Where, oh man.
Same thing, really. I wonder, what did you call the reference? Because I know it's pointed to. What's the reference? Is it reference of, the reference to?
I think it's reference 2.
Probably a reference to. That would make sense.
Yep.
That's how language works. There we go.
Hey.
That way you just copy point and name the reference. That is a sensible thing to do as well, because a reference is just a fancy pointer. Or a point is a scoff reference, I suppose it's the way to. Also, the AC is really drying out the air here, so I'm gonna go get another bottle of water from you. We'll be right back.
Legendary. Okay, integer. Oh no. Okay.
Is implementing the function and struct going to be more difficult though? Because those are like nested, like arbitrarily. Well, I guess the other ones are too.
No, you're right. These function and struct ones are real hard hitters. Because as you can see, we have this little star here in like our little format description.
Right.
And this means that there's like X amount of these, and then however many amount of these there are is described by param count.
I see. Okay.
And then same thing with like the member count for structs. So it's kind of like we store a bunch of like 8 indexes, and then after storing like a bunch of dummy zeros, we actually go through and store all the member types, and then we go back through the indexes and fill them in.
Oh, okay. I see. Yeah.
But you're right. That is like the hardest part about all this is like if we were just serializing arbitrary integers and arrays, it really wouldn't be too difficult because you couldn't get like a reference can reference another reference, but at some point it has to reference something that isn't a reference.
Exactly. Yeah. Like an int or something.
Yep. So then you just like, it's kind of recursion with an end stop.
Right.
But when
with the structs, yeah, they can reference each other, right?
they can reference each other, so you can have mutual recursion, and then you can also have a struct that references itself.
Oh.
Because you can have a struct with a pointer to itself as a member.
Jeez. That's going to be fun.
Yeah, but we think we've come up with something that deals with all that.
Yeah.
At least it should. Type integer. So this is an arbitrary integer. So we should have a bit width and is signed. Perfect. So what do I have here? Bit width and then is signed, right? Perfect. Hey, see the ones where we can just have a struct and deserialize that is so easy.
Yeah, literally.
That's when structs and functions kind of break down. Okay. This is gonna suck a little bit.
So the basic idea is to have a forward reference index into sort of the pre-generated table of types. Is that correct understanding? Or
Yeah, that's a great way to put it too. That's way more succinct. I would have taken like 8 paragraphs to say that. That's really good. Yeah, we have an index, and then that basically doesn't matter where it is because we already know the pointer that refers to.
Right.
And it won't change.
That's cool.
It is. I'm happy that Saraid was here because I think it would have taken me 8 years to come up with anything like that. That's why I just start things. Because if you start doing something, people will yell at you all the ways that you're doing it wrong.
Exactly.
We didn't store alignment. Okay, yeah, we're gonna have to do that one. Or do we? Or do we just determine alignment again? Yeah, we can't do that because the user can have align as. Oh my. Hey, kitty. Okay, I'll be right back. I'm gonna check on my cat. Don't go crazy, but you
Sounds
know.
good.
I'm back.
Welcome back.
Thank you. Nothing blew up, right?
Not that I'm aware of, but you never know.
Nice.
What's the name? Is your cat like one of like the terrifying cats, or are they like a nice cat?
Honestly, they're really nice. They very rarely claw.
Nice.
I've had
Love
cats. The problem with this one is they're very entitled and they like to like climb on people.
Well, I mean, isn't that just most cats?
It's true. That's true. I did just describe all cats. Oh, we have a question in chat. Audi, how did you make your first million? I don't know yet.
All right, I'm back. Where we at?
We're just describing how I made my first million.
Interesting.
I haven't yet, is the answer.
Mm-hmm.
Yeah.
I see the question now.
What do we got? Oh, Sir Aid, we screwed up.
What did you do?
You made
I didn't know I encoded.
structs don't encode their alignment, bud.
Oh, we forgot about that. That's not good.
Right?
Yeah, we kind of need to. They kind of should.
Okay, just making sure.
Ah, we forgot about alignment. That's a classic. Always the
You could
one
always
thing
just
I think
align
about.
all structs to like 20 million bytes.
That is one option. Another option would be to
Oh.
recalculate the alignment. Unfortunately, both of those will fail as soon as we introduce an align as specified.
Which we have.
Want to have in some case. Do we already?
Yes.
Fascinating. I keep forgetting things. Okay, in that case, it fundamentally is just broken. Because we need to store the alignment because the user might have specified it.
Something like that.
Sure.
Okay, is there anything else that we may have forgotten?
Size, maybe?
But that's determined by the types of the members, right?
Yeah, and from the alignment, you can realign it. Yeah, sure. That is an option, but also it's 4 extra bytes. We could just store it too. We don't have to recalculate it.
That's true. How would we recalculate it? When do we normally even do that?
How would we recalculate it? We'd
Well,
have to realign the struct.
That's when we type check the struct.
Yeah. We'd have to so we'd have to find the alignment of each. Oh, hold on. Are we storing the alignment of the struct members?
No.
We need to do that too.
Wait, of members? Why?
Offsets of members because we might want to align them differently too. If we put align as on a member, then we need to insert padding before that. So we kind of need to know the offset of. How are we doing that currently? Are we storing the offset of struct members in BST?
The offset of struct members in the AST. Yeah. We're calculating them right here.
Yes, I know that we're calculating them, but okay, member byte of. There we go, member byte of. So we just save that for remember, save the byte size for the struct, is what I'd say. Otherwise, we have to redo all the work again, and we can, if we're just storing data, we want to just store it. A few extra bytes.
Okay, I'm just gonna give a little PSA. Everybody that's listening right now, you're probably a programmer. If you ever feel like doing something from scratch, right? Because it'd be cool. Just remember this moment. When you're over 100 hours in, way more than that at this point. Yeah, I'm like 10 days of work in, right? Assuming like 24-hour work days.
Yeah, in that case, it's actually 30 days versus a month of work.
Yeah, there you go. So let's call it a month of work. Next time you want to do that, just remember this moment when you're implementing the deserialization of types and you realize that your entire serialization of struct types isn't going to work and you forgot everything. So you have to go rewrite the serialization of struct types. And then when you go to do that, you realize that not only did you do struct types wrong, you also did struct types doubly wrong. And you're going to have to rewrite the whole other part that you didn't rewrite. Not only do we have to add alignment, we're also going to have to go through every single member and add something into those.
Yeah, we'll have to add offsets to each member. Also, my room is now approaching the desired temperature, which means my AC has turned down the fan, which means I can finally take off these headphones.
Hey.
Now I'll be able to hear again.
His ears work.
Ah, there we go, better.
Okay, so if we have
It's a
member.
very painful moment.
For an extended period of time. It's annoying because I wear glasses. So it gets
Same.
in the way.
Same.
Hey, we're all blind.
Yay! We can be blind together.
That's right. To do alignment. Where does that happen?
What do you mean?
So where do we write bytes? So we write the member count, and then we reserve all the member types.
And we also need to reserve space for the alignments.
Well,
Or member offsets rather. Member offsets, struct alignment, my bad, member offsets, which is the same as you can derive that from the alignment. So it's the same information, just represented differently and already consumed. Yes?
I'm gonna blow up. Okay, here's my question now.
Yes.
We have to store something for each member,
Yes.
that being a name
Yes.
length, a name length, an alignment. No. Do we need the alignment of each member?
No, that's no. The offset is the offset is the alignment basically. Yeah.
Did
What
I?
gives us the alignment,
Okay. Okay, so we don't need the alignment.
rather. Mhm.
Okay, so for each member, we have a byte offset and a name length that we need to store.
And the type, yes.
And the type, shit. Okay, yeah. So at this point, it'd be easier, instead of just storing. Okay.
Yes.
This is so hard to put into words. Instead of storing a type offset, a type index, right, for each member,
Mm-hmm.
and then storing the name length for each member and the name, why don't we just kind of conglomerate all of these and have a struct, like serialized member, that we then reserve that many, like member count serialized members?
Yes, that is exactly what I would do.
Okay.
I was kind of assuming you were going to do that.
Nice. Okay. I couldn't even put it into words. I was a little behind on that. Serialized member. And then this is what? Type index?
Sure.
Name length?
Sure.
What else?
Byte offset.
Thank you. What did I... Oh.
Ah, yes, a U in 23T. My favorite.
First time chat from Not So Red. They said, hey, Discord link isn't working for me.
It should be.
Did I break it? Oh, please don't tell me I broke my Discord link. It's in every description.
Did you break it? It
I-
might have expired. Did you set it to not expire?
It has infinite expiration. That's what I set it to.
Okay, and infinite uses.
Yes.
Okay, good. I'm just asking because Agma didn't manage to do that, so
How do I...
his links expired, so I know that problem. That's why I'm asking.
That's my
So
donate link.
Don't know what's going on there. Do you want me to
Okay.
try like using the link on my alt? I'd have to switch to my alt first.
I just tested it in a incognito browser. It did work.
Okay, so I don't know. It's
Unless-
probably the then.
Yeah, unless it failed past that somewhere.
If we'll pass that, then I don't know.
'Cause-
Shouldn't.
I got to the accept invite button. Maybe a problem in my end. Let me try restarting Discord. RIP, yeah.
Restarting Discord might help. I'll be right back. I gotta put a keep send on.
All right. All right. So we have some sort of serialized member, which has a type index, a name length, and a byte offset.
Do you have to
Jesus.
store the name itself or just the length?
here's the hard part. We don't know how long the names are going to be. So
Oh.
this is kind of going to be like the serialized member table entry. And then after this table of members, we're going to have all the names. I know this is
Right.
confusing. So we're going to have like the struct header, the member table, and then the member names. And then this is basically just going to be a null terminated, not even null terminated, just all the names in a row of the members.
Right, yeah.
And then to
Kind of
determine.
like how strings are stored in an executable.
Yep, exactly.
Cool.
Okay, where are we at? Struct types. Yep, we broke everything. Phantasmo. So we want to write alignment after the member count. Well, the member type. So the member types is not going to be a uint64t anymore. It's going to be a serialized member. And then this isn't going to be uint64t anymore. It's going to be a serialized member.
Right.
Hey, welcome back. I think I've done the change. The struct now exists.
All right. Let's take a look at that. Hold on. I'm not sure I can tell the difference, but sure.
Yeah, not much has changed. Basically, we now use size of serialized member.
Sure.
And then this is serialized member. We have a type index.
For that.
Okay. Name length and byte offset. So then here, what is the name length?
Sure.
What is the... Also, member offset is a confusing name now. What is the name
Oh
length?
god, it's called member offset. Yeah.
And the byte offset. So luckily, we have the byte offset.
We do.
And we also have
We
the
should.
name. Okay.
Size T, so we'll have to cast it for just stop complaining, because for some reason we allow alignment to more than or structs that are larger than
4 million
what is
bytes.
2 billion bytes, 4 billion bytes.
Is it 4 billion or 4 million?
4 billion. 4 million would be rather sad.
But isn't uint 64 to 18 billion is the max?
Gigabyte is a billion. uint32T is 4 gigabytes. Otherwise, we'd
Yeah,
only
you're
be
right.
able
You're right.
4 megabytes in 32-bit mode, and we would have to add switch. I can't talk today. Would have switched to 64-bit a long time ago.
Okay. That's a good point. I forget the giga mega. I forget those are numbers instead of just words.
They are Greek. That's why it's all Greek to you, probably.
It's all Greek to me, man. I don't know what's going on. Okay. So we have all the member stuffs different. Yeah.
Sure. Yeah, sure. That's right.
Okay. So now we have to.
Calling serialized type in. I like that you're calling serialized type in the thing. That's clever.
Yeah, how bad can it be?
Fundamentally, we are pushing into the thing. That's the first thing we're doing, right? Pushing the type into the type cache.
Yes.
Like the first thing we're doing in the function, right?
Yes, that's done before anything
Good.
else.
Good. In that case, it should work.
For self-referencing, right?
Yeah.
So after we add to the size, we need to write the alignment.
Oh. What? What? Oh, I see. I was a bit slow there. You're reserving space. That's where you're adding to the size. Yeah. Sure. Sure.
Yeah, that does look weird.
A vector resize somewhere? But that doesn't save. Yeah, sure. Okay. Okay, no, it's fine.
Okay. So we write the alignment.
We don't have vector resize, do we?
Wait, what?
We don't have vector resize, do we?
We
Don't
have
work
vector resize.
because resize does exactly that. It reserves and also sets the size.
We don't have resize. I swear we have something that does resizing. I just don't remember what it's called.
Okay, I mean, it doesn't. It's not that important. We could make vector resize, but it's not that important.
Yeah, we just have reserve. That's what it is.
We seem to only have reserve, but it's true.
Oh well, that's fine. We don't need it. By the way, I figured out something just now. We don't need to store the name length in the member serialized member struct.
We don't. Are we storing somewhere else?
Well, here's the thing. We kind of store strings in this module metadata format in a specific way where we write 4 bytes for the length of the string and then write the string.
Yeah, well, duh. We don't need to store the name length twice if we're storing somewhere else. Yeah.
Yeah.
Okay, yeah.
Technically, if we stored the name length here, it'd be easier to skip to the next thing without parsing each name.
Oh, we don't need to skip ever, so we can just pass it.
Right. So we don't need the name length technically there.
I was assuming that you were going to encode the name length here and just the data all at the end. But if we're doing it as strings, as serialized strings, then yeah, sure. We don't need the name length in the member.
Yeah, and I think it just makes more sense to keep the string serialization the same, even though we could.
Sure.
Yeah. That way we can just write a helper that's like parse string.
Sure. We are writing all of the names before we try to serialize the member types, aren't we?
Yeah.
Okay, just making sure that we don't make any stupid mistakes here.
So we have the member count.
Okay, enough. Member count.
We have the serialized members, which is the
Yeah.
type index as well as the byte offset.
Yes, that makes sense.
We have the alignment.
Sure.
We have the name of the struct type.
Sure.
And then we have the name
The names of the members.
of the members all written with the length and string.
Then all the
Fix ups.
Okay, yeah, that looks right. That looks right. Okay.
So this is writing member names, writing struct type name, writing alignments, which I don't really need a comment for, but whatever. Writing member table. And writing member count. That's simple, huh?
Mm-hmm. Nice and easy.
Redone. Thank you so much for joining the Discord. Good to have you.
I've turned off the AC for now. It's so quiet in here now.
Could drop a pin. So that's apparently structs done.
I think so.
So now we just need to deserialize them.
Yeah, which should be just as easy as serializing them.
Oh dear. Oh dear. I don't know if I should probably go, otherwise I'm not going to eat dinner.
Been 4 hours.
What'd you just say?
It's been 4 hours.
It's been 4?
4.
Oh
yeah.
my god.
We are 4 hours, 13 minutes into this.
Well, now we kind of have to wait 5 minutes. Have an exactly 420 video stream, right?
Oh my god, sure.
Okay. All right, we've got 5 more minutes, everybody. Thank you
Yeah.
for tuning in. Be sure to check out the YouTube if you haven't already. There's videos there of every single stream I have, so you should go there and watch my videos, I guess, if you like this sort of thing. There's lots of them. Lots. Okay.
We're on, what is this, like 50?
This is 61.
61. Fascinating.
That's right. I think it's 61. Yep, 61 for the compiler.
Uh-huh.
What are you going to do on part 69?
Ooh, part 69.
Coming up?
69. Maybe we'll be done with modules by then.
Maybe.
So,
I don't know if we'll ever be done with modules, to be fair. Do we have similar issues with functions? Do we need the alignment of functions?
What do you mean the alignment of a function?
Like, we don't, but structs we needed alignment and we forgot it. Is there anything that's not here that we would need for a function type?
Functions, let's think about this. We need the name, the mangled name.
Oh, shit, the name. Hold on.
Did you forget about the name?
Hold on.
You forgot the function name is what you're telling me. I doubt that.
You did too. It's not here.
What do you mean it's not here?
forget the name.
We need both the name and the mangled name.
Oh, we are very
Name for overload resolution, the mangled name for linkage, for linking.
Oh, wait.
Wow.
I think I
What?
discovered it. Okay.
Is it in here?
So the type doesn't have a function name.
Sure, the type doesn't have that makes sense. Yes.
That's what's happening. Okay. So
Are you also serializing the mangled name of each declaration?
no, I thought we didn't need to do that.
Right, we do.
Why?
Why? Because some functions are mangled, others are not. If you try to call a mangled putchar, you'll be very sad.
But
Also,
isn't
think
no
that-
mangle an attribute?
the open, so I'll be right back.
Okay. Isn't no mangle an attribute? Am I crazy?
Wouldn't that just be like the equivalent of like extern kind of? Or is that something different?
Yeah, it's really complicated. It's kind of a gray area right now because I haven't fully decided how it's going to work. But basically it kind of goes, here's the general issue, which is that we have a no mangle thing. And this is needed so that like from C, you can just call sum2 impl. And you don't have to call some crazy mangled name. Right?
Right. You're mangling it for overloading, right?
Yes. So we could technically have like multiple sum2s, right? And yeah, overloading requires mangling because if you have two functions which have the same signature and the same name, or not the same signature, but the same name, then it's you have to be able to distinguish calling those two at some level.
Exactly. So it's totally out of the question just to like recalculate the mangling, right?
It's not. That's why I'm curious whether or not we'd have to store it. Because all the mangling... Well, Okay, no, that's not an issue. I just went down a whole road in my head. So the thing is, like, if we mangle a certain way for one platform but not another, which would happen for, like, what if this certain assembly for this one instruction set architecture doesn't allow underscores or something?
What?
In symbols?
Oh, wow, I didn't know that.
Well, no, it's not. But like, for example, a real example would be like dollar signs. Dollar signs are fine in C and C++ identifiers, but they're not okay in assembly.
Right.
Because the dollar sign generally refers to like a special symbol, like the current address or stuff like that.
Yep.
So to get around that, you do have to mangle names for that as well, where you can't encode things. But it may be different per backend, but each backend will only compile into a one format, right? That's kind of what the backend is. So then when we're deserializing, if the module was compiled for a different architecture, different format, then the mangled name wouldn't match. But that would mean that you're trying to use like an x86-64 module, like compiled for x86-64 on an ARM machine.
Exactly.
And I don't.
Is that a use that you want to support?
Yeah, I was like, I don't think that's ever going to be an issue.
Okay.
What's
So-
not an issue?
We should just be able to regenerate mangled names.
If you know whether it's annotated as no mangle or not, then yes. Otherwise, not. Otherwise, we don't know if it's mangled, even if it's supposed to be mangled or not.
Fair, fair. So now the question is,
Whether
Also,
it's-
use seconds.
all right. So we have no mangle here. We could just have it a serial attribute.
you can store that, but the thing is, it's a question of do you want to make the thing big or do you want to recompute? Because you're gonna need the mangled name anyway, probably. If you're actually only if you're using it, I suppose. Which might be an argument for not storing it.
Right.
So it works either way.
Okay. Also, I overshot the 420 stream.
So close.
F.
So
It's
I'm
so far.
I'm now going to go within the next 10 minutes. It'll be within 420.
For 20, we go to 69. So 6 hours, 90 minutes.
Oh my gosh.
6 hours, 90 minutes. I love that. Not 7.5 hours. No. I don't. So what you're saying is we have everything except the function name.
Yeah, this makes sense if it's a function type.
Who needs function names anyways?
So the idea is any named function would actually be called by name, would be an export, would be, yeah, okay. Oh man, I just blinked and my eye went blurry. I hate that. It's only one eye too, so everything gets really disorienting. Ah. There we go. All right. Well, thank you everybody. This has been awesome. We got a lot done, I think.
Mm-hmm.
We have lots of errors, so that's good. Initialization of type pointer from incompatible to type pointer.
We did the thing again, probably.
Where did I do the thing again? I did do the
92.
thing.
There we go.
I did the thing again. What did I do?
That's brilliant.
What am I?
You're returning type. It's either it wants a uint and you're returning a char pointer or the other way around.
No, I'm returning a type pointer, and I don't know why.
Okay, that's also an option.
That's quite odd. Okay. So then we'll just do an unreachable out here,
No,
and then we'll return.
this is deserialization, isn't it?
Yeah.
Okay, you can also do this, sure. I suppose
What else
you're
would I
not
do?
Right, I suppose that makes sense because I thought you would be adding to it, but that makes more sense because this is, yeah. This isn't a template or anything. Yeah, you can do it this way. That makes sense. Sure.
You at 8, I think, right?
Oh, thank you. I'm a genius. It's a uint8t pointer. I was thinking it returned the amount.
Mm.
Okay, so
You need to cast it.
yeah, that's a good point. I don't need to cast it. Okay. Legendary. To do. I guess we'll just make this a to do call. Deserialize structs. Deserialize functions.
For sure.
Yeah. We'll be fine. Return from +1 plus size of serialized type array. Return from +1 plus.
Horribly on ARM.
Would it?
This always crashed so horribly on ARM because ARM has aligned accesses only. So all of this will just crash horribly on ARM.
I'm pretty sure the
Mhm.
compiler handles that for you, doesn't it?
No. If it did,
Yeah, it
you
does.
would not be able to do it performantly. No.
Well, that's the yeah. Then it doesn't do it performantly. That's why the joke is like, oh, ARM is efficient, but it takes 8 times the instructions.
No.
Why are you saying no?
Wait, like
ARM
aligned accesses you're talking about?
Yeah,
ARM
it's
has
a whole thing.
64-bit
Yeah.
values. So the compiler assumes that they're aligned properly because them not being aligned properly is undefined behavior.
Yeah. that's
Otherwise,
true.
you'd have to load bytes individually, and that is not a thing. Compiler will not do that.
Well, then ARM is something we'll never support because it's a dumb compiler.
What I'm using right now.
Well, if your compiler, it's not your fault. It's the whoever made your stupid compiler that supports that platform. Because apparently they don't want to make code work. They just want to make, oh, if your code isn't efficient, screw you. It will never work, which is stupid. It's
I
like,
mean, if you have code that like does
LVM lets you specify an alignment for each load and store. So you can always use alignment 1. It'll do something that works on the platform. It can do that, but it doesn't do that. Clang doesn't do that by default. Because that's not the semantics of C and C++ are.
that's cringe. Oh wow.
so what you're saying is they know how to do it, they could do it, and they still don't.
The reason is because these languages are so old that back then that would have been a very noticeable performance difference, and it might very well still be one today if you're doing that in a loop. And
Well,
back
performance doesn't matter if the question is the code compiles or the code doesn't compile.
performance does matter. If the code compiles but it runs way too slow to be of any use, then it doesn't help anyone. Like you could
Yes,
compile
it does. Because it compiles and you can see that, oh, this method is too slow. I have to write a different one.
Or
Right.
aligned.
No.
Because
Not
there's
if it's-
no way we can do this aligned. And it's like ELF isn't made that way. ELF has unaligned accesses all over the place. So how do they write ELF libraries for ARM?
Memcopy.
Fuck memcopy.
Wait, why can't you do this with like actual aligned accesses only?
I mean, we
Seems
could.
like-
It just we could never store 1 byte. We'd have to. We don't know how long a string is. How long's a string?
That's well, I mean, you are putting all the strings together in one sort of aggregate string, right?
No. I mean,
Oh, you're not?
yes, but also no. We're doing that partially for each struct. The members, all the names of the members just go in one big chunk.
Oh, I see. Okay.
Oh,
Hold on.
Sarade.
Hmm?
Sarade, it's broken. Oh, it's not broken. I'm just dumb. Never mind. We're good. We're good. We good. Okay, I have 2 minutes to wrap up. Otherwise, I'm not going to even be in the 420 anymore, and I'd be a disappointment to Weed. Mary Jane is the one person in this world I will not disappoint.
Right. It's time to wrap it up then, I'd say. Because if you want to wait till this is done, we'll be here for another half an hour or so.
That's fair. All right. Do you guys have anything to plug? What do you guys do? What are you working on?
Not particularly anything currently.
Okay.
I'm just doing the same stuff as you, to be honest. I'm coding a compiler in C for a language that I'm making.
That's
So
awesome.
I'm like super fascinated by what you're doing. Really cool.
That's awesome. Thank you. I'm inspired by what you're doing. That's so cool to see that more compilers are being made.
Yeah.
What kind of language?
Maybe,
Open source, so
it's I think the best way to describe it is probably a love child between Risk 5 and Forth. I don't know if that makes any sense. So
Yeah. It's that's going to be good.
yeah. It's a very minimalist, sort of simple language, but the idea is that it has an ISA that's as close to the hardware as is portably like possible, to, I guess, obviously RISC-V, ARM 64 and 32-bit, and hopefully x86, although it's gonna be difficult, I guess. But yeah, very, very, very low level kind of thing.
That's exciting. That's exciting. Be sure to join the Discord to stay tuned on that project. Ooh. Okay. Yeah. This stream has been about Intercept. We did a bunch of stuff. We're working on modules for it. I did a bug fix this morning. You're welcome, Mr. Mugame. This has been a stream on Twitch. Go follow on Twitch. Hit those buttons. We like the Twitch streams. They're lots of fun. And we like having you guys here. This was a Twitch stream with you guys involved. We're in the VC public in the Discord, so be sure to join, and you might even be able to be a part of the next stream, like a door handle here and Eternal. Dwur something.
Sure, yeah. Whatever.
I have a YouTube channel. It's youtube.com/LENSR. You should go there. There's a ton of stuff. I have a blog too. I write there like once every few weeks. It's about programming mainly, and sometimes about life. It's got all the links. That's mainly why it exists. Anyway, I have a text editor and an OS that I work on sometimes. So if you're interested in low-level awesome stuff in C, C++, Lisp, I'm going to be making a VM most likely soon. I'm going to be making a Lisp that compiles to that VM. We've got plans in the future, so if you like stuff, be sure to stay subscribed and stay tuned. Yeah, Serate isn't doing anything public right now, but he is working on a compiler for a language called Source. I'm very excited for that. And Dwur is also working on a compiler. We got 3 compiler devs here. Welcome. We're the start of the next generation of languages.
I love how it's not even bothering to hide my name.
That is pretty funny, I know. They're like, oh, it's your display name.
I have a different display name.
How do I do that? The new Discord is so crazy. Anyway, thank you all so much for watching. This has been amazing. And yeah, Mama Rolfs is waiting for your next stream. Awesome. It'll be soon. Hopefully sometime mid this week if I have time. All right, any last words?
Not particularly, I think.
This was a fun stream. Hopefully I can come at the beginning next time.
Awesome. Yeah, absolutely. And if you want to come at the beginning, be sure to join the Discord. Get announcements every time I go live. Thanks everybody for watching. We'll see ya.
Ta-da.